So good morning. My name is Julius Knapp. Everybody calls me Julie, and I'm the head of the Office of Engineering and Technology. So today you're getting three sessions in one. You're getting both Spectrum Frontiers, millimeter wave, and 5G all wrapped into one session. This is really an exciting day. I've been here long enough that I still remember the first conference when we talked about moving from analog phones to, we didn't even have a name for it then. And who thought you needed something more than a wireless phone at the time? And it was the first session about PCS. And can you imagine we talked about one day having phones on your wrist? So I hope we have a very exciting lineup for you today, and I hope that for all of you, that when you look back, you'll see this as a landmark day for the kickoff of yet another generation of wireless communications. We have a great program, and to get us off to a great start, it's my privilege to introduce Chairman Tom Wheeler to get us started for the day. Thanks.
Thanks, Julie. I remember that day too. We can't be that old. Dale Hatfield, of course, would remember that, but I think that's a great analogy to draw, because we are at that kind of a hinge moment of history. So I want to welcome everybody here. It's a glorious spring day in your nation's capital, and so we've decided to lock you up in a basement windowless room. But thanks to everybody, thanks to the speakers, thanks to the vendors and the exhibits, and thanks to Ted Rappaport for his thoughts, what are going to be his thoughts on this whole issue. I also would be highly remiss if I didn't talk about the great job, underline great job, that Julie's OET, the Wireless Bureau, and the International Bureau are doing on moving us forward on this issue. I am also kind of the Ed McMahon warm-up for Commissioner O'Reilly, who is going to follow me. I look forward to his remarks. This is very much a bipartisan issue. Commissioner O'Reilly was at work, dealt with this issue and some of its frustrations while at work, and is a leader in our thinking here at the Commission as it develops and evolves, particularly on the how do you deal with millimeter wave spectrum issues. But let me be clear about one thing, and I think that Commissioner O'Reilly and I are in violent agreement on this, and that is that 5G is a national priority. This isn't just an issue of the next technology to come along. This is an issue of national leadership. This is an issue of new opportunities for consumers and enterprises to benefit from the next generation of connectivity. This is an opportunity for the economy to grow based on the fact that the United States will lead in the rollout of 5G. And our approach to that is twofold. One, it is spectrum and spectrum policy. And second, it is open innovation on that spectrum. We do not believe in industrial policy that sits down and says, this is how you will behave. Julie referenced the evolution from TDM to digital. It wasn't always pretty. I remember. I was there. But it did make us the world leaders in 4G. And we intend to continue that leadership in 5G. But it all starts with spectrum, the mother's milk of connectivity in the 21st century. Our establishment of spectrum and our allocation of spectrum and our open application of spectrum for 4G made us the world leaders in 4G. And we are going to follow that policy again. And we should think about that across multiple spectrum bands. We're going to need high, mid, and low spectrum for 5G. Again, because we aren't going to say you have to use this for this, and this is how you're going to behave, and this sort of thing. We're going to let those of you who are innovators innovate. I want to thank in particular our friends from NTIA and the DoD who are here today, because they're going to be integral parts in how we roll out access to spectrum. And we look forward to working with you on that. I want to pause for a minute, if I can, and see if I can reflect on some comments that were reported in the press yesterday about some comments I made Monday night at the SIA meeting, in which I was rather direct in terms of the disappointment with some of the activities of the satellite industry at the World Radio Conference. And I won't go and rehash all of that. But I think that the response that I heard from the industry was that they understand that sharing is the future, that obstructionism is not, and that is a two-way street. That I said in the in my remarks that I hope that the satellite industry and the mobile industry would get together and work on how they can coexist, because the future of spectrum in the 21st century is a future of sharing. And I've been encouraged since my remarks at the feedback that I've heard from the satellite industry, and I hope that we see that kind of feedback from the mobile industry as well. This is very much a two-way street. This is there are expectations on the mobile industry to meet the satellite interests in a fair and open and equal manner. And there is a reality hanging over everything that there is a priority that if this isn't done, if the industries can't come to us with some kind of a recommendation, we'll be forced to make a decision ourselves, simply because this is so damn important as a national priority. So I think that we all need to assume that we will be moving forward in good faith on both sides, and we look forward to the results of those good faith efforts by both the satellite industry and the mobile industry to talk about how do we share spectrum. The other key to national leadership, of course, is once that spectrum is allocated, how do you use it? And we're not going to stipulate that we're not going to micromanage the use of the spectrum. We are going to rely on the creativity and the innovation that comes from competition to move forward on 5G technology. It is a mistake, I believe, to say we're going to wait for standards. We need to make sure that there is spectrum, and the innovation will follow. And that innovation, we want to make clear that we are open to that innovation, and including the fact that that there may be standards that continue to evolve over time. Finally, we can't forget the fact that 5G is going to be infrastructure intense. It's kind of strange when you stop and think that the wireless future depends on wired connectivity in so many ways. But the backhaul that connects all these are going to have to dig up streets, hang cable, and site antennas. So we can't get so focused on spectrum policy that we forget that the other key component of this national priority of 5G leadership is how you build out the infrastructure. We need to be sensitive to the concerns of our communities, and at the same point in time, we all, us, those who are building out the infrastructure, and those who represent local citizens, need to focus on how do we dig once, how do we climb once, how do we site once. And so, as we go through this debate, this discussion about the next generation of wireless, let's remember not just the stuff that's up there, but the stuff that's on terra firma, and how we have to make sure that that comes along in parallel as well as on spectrum policy. As I said before, I'm the warm-up act for Commissioner O'Reilly. It's my privilege to introduce Mike O'Reilly to you now. This is something that this is a topic that I have had the pleasure and privilege of watching Mike O'Reilly become personally involved in. I watched him in his activities in behalf of our country and our leadership at WRC. It's a privilege to serve with him on this commission, and I'm pleased to introduce him to you now.
Well, thank you, Chairman. I think you might have ruined one of my jokes. I knew I had a little bit of time when I was sitting there because I noticed you walked up without too many notes. So I want to thank the chairman for his kind words and thank him for being my warm-up act. I am so used to him getting the last word at commission meetings that it's nice to have turned the tables just a little bit. Joking aside, I'm so pleased to be with you here today to learn from a number of experts on the front line of innovation and research on the next generation of wireless services. I have some written remarks, and if I learned anything over my years, it's to state a script, so I will try to do that as best as possible and then get on with the show. I also want to thank all the panelists for joining us and industry members for participating in the tech demonstration. Events like this can be useful in ensuring that the Commission has a more complete picture as we look forward towards next networks and opening of millimeter wave frequencies for additional use. My colleagues and I agree that for the United States to remain the world leader in wireless communications, we must be in the forefront of the next generation technologies. As I've stated before, our position is being severely challenged as other nations see the value in replicating our 4G LTE strategy by trying to be the first to deploy 5G. Any unnecessary delay risks another nation setting the terms of the next 15 years of wireless communications. We should all be committed to ensuring that this does not happen. As I waded through the substantial spectrum frontiers or millimeter wave docket, and yes, I've been known to delve into the murky waters of ECFS, and there are definitely some reoccurring themes. It's clear that there's no consensus definition or architecture for 5G. I'm hopeful that this morning's panelists will discuss anticipated offerings and applications, predicted technological solutions, and envisioned deployments. These insights are helpful as we open these bands. But there must remain mindful that there are many uses, equipment, and standards that are likely to change over time as we proceed to wide-scale deployments. This raises an important question. How does the Commission facilitate such a developing technology? First, to achieve the predicted increases in speed, latency, and capacity, we know that spectrum and dense network systems requiring backhaul and infrastructure will be needed. Second, as recognized by many commenters, the Commission must permit a certain degree of flexibility in order to promote innovation and investment. Basically, the Commission needs to provide some raw materials and certainty, prevent its requirements from being caustic, and then get out of the way. On the topic of spectrum, to achieve the promise of next-generation networks, additional licensed and, where applicable, unlicensed bands will be needed in both the traditional low and mid-band spectrum, along with frequencies above 6 gigahertz. Today's event is focused on the millimeter wave frequencies, and so will my comments. While the Commission's NPRM from last October was a helpful first step in opening up the 28, 37, 39, and 64 to 71 gigahertz band for additional advanced wireless services, far more needs to be done. And this starts with adopting an order to allow for flexible use of these initial bands and issuing a further notice in early summer. In regards to the NPRM, the Commission must move forward on the 28 gigahertz band despite the disappointing outcome of last November's World Radio Communication Conference. Further, similar licensing paradigms should be used for 37 and 39 gigahertz. These contiguous bands should have similar license areas and terms in order to promote investment, research and development, and deployment. Therefore, the hybrid licensing proposal for 37 as outlined in the Commission's NPRM, should be discarded, in my opinion. This afternoon's regulatory panel will likely provide a lively conversation about regulatory and licensing models, but we must keep our main focus on the goal of 5G deployment, not on some time of experiments. Moreover, the Chairman promised last October that we will do a further notice this coming summer will expand the scope of millimeter wave frequencies to be considered. Going forward, the Commission should seek comment on as many spectrum bands as possible within reason, including those mentioned in the Commission's notice, the WARC final report, and any others in which the industry has expressed interest. As you all know too well, incumbent services in the same or adjacent bands may present challenges. To have a sufficient pipeline, we must start to identify issues, determine whether clearing is possible, or in the alternative, sharing is necessary, and establish a time frame in which the spectrum may be available. Some bands will take longer to study and others may be determined to be ill-suited for 5G offerings, but we need to lay the groundwork so we can weigh all of the options. One thing is certain. It is not acceptable to say that a band is just too difficult. As we consider these millimeter waves, we must be open to spectrum blocks that total less than 500 megahertz. Such bandwidth should not be considered less desirable or automatically off the table, especially since we do not know where technological enhancements will take us. While many are focusing on the ability to download a 4K movie or television or mobile device in a split second, these networks will also need to connect the vast Internet of Things. Some applications will not need to be as bandwidth intensive as video or require the same speeds or latency. It is also critical that we take into account the spectrum may be needed for backhaul. Fiber is likely to be too expensive to deploy to a dense network or 5G access points. Many stakeholders believe that wireless backhaul may be needed to connect multiple small cells to another access point that is connected to the fiber network. Therefore, sufficient spectrum will be needed to deliver content not only for devices, but also to connect access points to backhaul. I hope that participants will discuss other means in which the Commission can help facilitate the deployment of needed backhaul to support these networks. The densification of networks will result in an increase in facilities serving as access points and providing backhaul, which leads me to a topic I often discuss, the need to reduce burdens on infrastructure siting. To realize the promise of 5G, companies will need to expeditiously deploy equipment in a cost-effective manner. To facilitate network deployment, the Commission must fulfill its commitment to expand upon the historic and environmental process relief provided to small cell and DAS installations. But even this action, which will be tremendously helpful, is not a cure-all. I continue to hear complaints about permitting problems, excessive fees, and de facto moratoria. Site approvals in rights-of-way, which are essential for small cell systems, appear to be particularly problematic. I hope that panelists will take some time to discuss ways to ease the burdens of facility siting. Because even if we were to have infinite spectrum resources, which we do not, without substantial network deployment, the American people will not benefit from 5G technology and wireless broadband services it may develop without infrastructure. So I want to thank you for listening to my quick and short comments. I welcome the panelists as we go forward. I will be coming in and out today. I have to run out, but I will be back because I do want to listen to the good comments and will participate. So thank you very much this morning, and good luck with today.
Just underscore something that the chairman mentioned. Behind the chairman and Commissioner O'Reilly, of course, the other commissioners are all on board and helping us to advance this. And I just stand up here representing OET, but we're also working in partnership with the International Bureau and the Wireless Bureau. I saw John Wilkins back there, and I didn't see Mindell, but I can tell she's probably hard at work just on these issues. When we were putting together the program and thinking about somebody to give a keynote, there was an obvious choice, Ted Rappaport. And Ted, I won't read the whole bio, but Ted is the David Lee Ernst Weber Professor of Electrical Engineering at NYU and founding director of NYU Wireless. Ted has been providing advice and support to the Commission for quite a few years. I don't know exactly how many that it's been, but it's been quite a while. When engineers think about advanced wireless technologies and where they can go to get trained and learn about them, they think of Ted. And Ted is an engineer's engineer. The kind of people who are solving problems before you knew there were even problems to solve. So it's my great privilege to introduce to you this morning for our keynote, Ted Rappaport.
Thank you, Chief Knapp, Chairman Wheeler, Commissioner O'Reilly, Deputy Ha, ladies and gentlemen. It's a pleasure to be here on what I believe we'll look back and view as a historic day. I think all of us will have a chance to get a glimpse of what 5G will be with the demos and the leaders we have from industry here today. The slides, I think, are they on? I have some slides that I think we can activate. The reason why this is so timely and such an important event in the history of wireless is, as I hope to show in the next few minutes, we're at a point in the information age where growth is beyond anything we could have ever anticipated. And particularly in the wireless industry, we've always seemed to lag what the applications and the new internet companies and products would demand. A graphic that shows this quite vividly is a large outdoor event in Europe, and you can see two photos in 2005 compared to 2013, and you can see the difference in the crowd and the electronic devices used for communications. In 2005, 3G was just starting its major rollout throughout the world. 3G was touted as the first internet-ready wireless standard. And it really was launched in Japan in 2001. And by 2005, the global wireless industry was rolling out 3G. Yet in 2005, Facebook was still the Facebook. YouTube was just founded. Companies like Twitter and Instagram didn't even exist. And the internet was still very new. You couldn't buy a laptop in 2005 with a gigabyte hard drive, 10 to the 9th. And today, we think about terabytes, 10 to the 12th memory sizes. In just 8 years, we went from 3G to the rollout of 4G, and you can see in the bottom picture with the advent of the smartphone and the wireless capabilities of 4G and download speeds now of 10 megabits per second and more. You can see now the world was ready and wireless was behind. We didn't have the capacity or the bandwidth. This chart by Cisco, the Visual Network Index, shows the growth of cellular on mobile data, all kinds of mobile data around the world. And what you see is shocking. You see more than a 50% compound annual growth rate projected for the next 5 years. In fact, we're going to go from 37 exabytes a month. And what's an exabyte? Well, exabyte is a lot of zeros. It's beyond terabyte, which is 12 zeros. It's beyond petabyte, which is 15 zeros. It's 10 to the 18th zeros. So we're going to have 10 to the 18 zeros bytes of information per month mobile this year. And that's going up at a rate of 50% per year. And so we're starting to use terms like exabytes that we've never really used before in the communications industry. In fact, what comes after exabyte? Well, the word is zettabyte, and zettabyte is one with 21 zeros. And you think about how much data a zettabyte is. All the world's data that exists today on the internet, mobile or not, all the world's data in 2016 will be doubled by 2019. That's staggering. I mean, doubling the amount of all data in the world in just 3 years. It's a clip that it just cannot be maintained if you do nothing. So I'm very proud of America and the Commission's stance to move up higher in the spectrum, where is the only way we can address this huge demand. By the way, it's not just Cisco, it's Intel and Ericsson and all the major telecom equipment makers that are forecasting these similar growth rates, 65%, 45%. And these don't even consider the breakthrough applications, the way YouTube and Netflix and Instagram changed the demand curve. If we provide the new spectrum and the wider pipes, we can see those new applications and capabilities that we've never even thought about. But we're sure not going to do it unless we offer up more spectrum, and a lot more spectrum. Let me just show you how far behind the wireless industry has been and why this is such an important day at the Commission and for our country. If you look at Moore's Law is the famous law by co-founder Gordon Moore of Intel, which described how processor clock speeds and memory sizes increase double every 18 months because of the shrinking size of transistors in our consumer electronics. If you look over the last 40 years at what Moore's Law has provided as a dividend to the computer and communications age, you see that from 1976, when first-generation mobile phone was in its very early days, amps, you could buy a personal computer with a clock speed of about 1 megahertz and a hard drive of about 256 kilobytes. A quarter of a meg was a very big hard drive in 1976. And cellular, first-generation cellular came out at 850 megahertz carrier frequency. Fast forward 40 years to today, and now you can have personal clock speeds of 5 gigahertz. That's a factor of 5,000 increase. The memory size has increased by over 4 million times, 6 orders of magnitude. You can now get a 500 gigabyte hard drive, even a terabyte hard drive in your laptop. Yet in the 40 years of the wireless cellular industry, the carrier frequency's only gone up by a factor of 3. A factor of 3. We've seen orders of magnitude increase everywhere, but in the carrier frequency. Now, there's nothing fundamental about not bringing Moore's Law to the wireless carrier frequency. We've just never done that. In fact, when you look at the frequency spectrum chart, and if you go across the page like you're reading pages of text, you'll see there's 7 lines here. This is the U.S. spectrum. And the top line goes from 30 kilohertz to 300 kilohertz. And then at the second line, the AM radio band is in the 300 kilohertz to 3 megahertz range. And you can see these little circles in orange. That's the cellular allocation at 850 and 1.9 gigahertz here in the U.S. And when you look at the entire radio spectrum that the U.S. has, and this goes up to 300 gigahertz. The bottom line is 30 gigahertz from the left to 300 gigahertz. What you see is that the entire 6 lines that are shaded, 6.5 lines of blue, all that spectrum, all the AM, FM, satellite, TV, cellular, Wi-Fi spectrum in the world, all fits within that small blue circle on the bottom line where the 60 gigahertz unlicensed Wi-Fi band exists today. This shows you dramatically how much more capacity you can get by having a little sliver of the spectrum chart at millimeter waves compared to everything we've ever done before. And this is what we need in order to be able to meet the capacity demand at 50% per year. In fact, it's worth noting that in our cars today, modern vehicles have lane-changing detectors and parking assist, all using 77 gigahertz millimeter wave electronics to sense where the next vehicle is. These are shipping in the millions. So the semiconductor industry is already there, able to make wireless devices at low cost with great efficiency up in the millimeter wave spectrum. Now, millimeter waves technically are 30 to 300 gigahertz, but for today, I'm going to call that 24 to 300 gigahertz for the spectrum frontiers at 24 gigahertz and above. But you can see that the green area is really the 30 to 300 gigahertz range. There's so much spectrum here. It's a vast frontier. And if we don't tap that for use in future mobile, we won't be able to keep up with demand. Now, what is 5G, and why do we need to move on this quickly? Well, NTT Docomo, which was the world's first deployer of 3G technologies and has one of the largest R&D staffs of any telecom provider in the world and is very active in wireless standards, has defined 5G in a way that I think is very nice and easy to understand. One is they're looking for higher density, more users per square kilometer. More users, more devices, the Internet of Things. Reduced latency, moving from today's 4G LTE 10 millisecond down to 1 millisecond. This will allow content to move quickly, and it will also allow tactile communication with devices, with vehicles, with machines, robots. And I think we're going to see some exciting examples of that today in the industry demonstrations. Lower energy, using more efficiency, and I'll show shortly one of the major ways we can achieve that energy efficiency through the use of antenna technology. Not only that, but we're looking at moving to much higher data rates, and this is where we need the spectrum. As the chairman said, spectrum's the mother's milk to wireless communications. And the only way fundamentally to achieve these higher data rates that are going to be key to 5G are to provide more spectrum bands. If you look at the data rates of the last few generations of wireless technology, you can see that 3G was able to achieve up to 5 or 10, even a little higher megabits per second. 4G LTE today being deployed is 50 to 100 megabit per second data rates, and over the next several years, as this 4G matures, it will bring data rates of a gigabit per second. That's 10 to the 9th, 9 zeros. Bits per second, full-length feature movies being downloaded in a matter of a few seconds. But to be able to achieve this 50% plus compound growth rate, we need data rates 10 gigabits per second, 50 gigabits per second. And the only way you can achieve that is widening up the bandwidth. And the only way you can widen the bandwidth is by allocating capacity at much higher frequencies. Remember that chart of Moore's Law. We've only gone up a factor of 3 in the history of the cellular industry in carrier frequency. When everything else around us, on the appliance, on the device, in computers and information, have gone up 6 orders of magnitude. We have to move much higher in frequency. Now, one of the myths in the wireless industry that's prevailed during this time is that millimeter waves are too hard. It's too difficult. The radio waves won't go as far because you have much more loss at higher frequencies. But I'm here to tell you, happily, that that's not true. In fact, the law of physics and measurements we've been doing prove that, indeed, the millimeter wave propagation problems are not that great, and in fact can be solved by one fundamental technology, and that is the antenna. To show you an example of how antennas will change, and there are already products, and you'll see some of these today, this is an example of a chip that my students and I made 7 years ago. On this chip, which fits on my fingernail and has a dimension of 1/2 of a centimeter by 1/2 of a centimeter, there are 16 antenna elements for 60 gigahertz, a popular unlicensed band. You can put 16 antennas on the tip of your fingertip. And these antennas work in concert with each other to provide a narrow, focused beam. The fundamental law of physics says, yes, you lose signal as you propagate with distance at higher frequencies. But the law of physics also, from Free's law, says you get back all that loss if you keep the antenna the same physical size at the higher frequency. That is, in today's cell phone, operating at 2 gigahertz, we have maybe 4 antennas inside of it. As we go up to millimeter wave, 28, 37, 39, I like to call that the 38 gigahertz band, 70 gigahertz. Instead of 4 antennas, we'll have 30, 40, 100 antennas. And they'll be the same physical size, which means we won't have any substantial signal loss. And that's something the industry has sort of missed, but now the U.S. has a first opportunity to move and to allocate and to prove to the world these bands not only work but are vital for providing the capacity that's needed. At NYU, we've been working for the last 5 years and conducted the world's first measurements, channel measurements in Austin, Texas, New York City, Brooklyn, deploying towers, deploying mobile systems, building custom hardware to prove that both indoor and outdoor and for peer-to-peer, device-to-device wireless communications, indeed, these millimeter wave frequencies will work. In fact, they may work better than today's cellular. What we did is, for example, in 2012, we deployed throughout the NYU campus in Manhattan different base station locations on top of the business school, on top of the gymnasium, different tower heights, and students worked tirelessly throughout the summer of 2012 with custom-made equipment with greater bandwidth than anything available commercially, and actually demonstrated how millimeter wave wireless can provide remarkably good coverage and that energy arrives from different directions. Those directions can be harnessed to be able to create the signal. The students would deploy pneumatic masts like you see on the right. They would take computers with a channel sounder, which is on the left, and would make channel measurements just like have been done in every other generation of cellular. But what was different, what was fundamentally different this time, is we used horn antennas as a proxy of the electronic devices that would fit into the cases of cell phones and Wi-Fi access points. We did these works at 28 gigahertz, at 73 gigahertz, at 38 gigahertz, 60 gigahertz. And what we found is that no matter where we went, whether it was Austin, Texas, or New York City, using only 1 watt of power, just 1 watt at the transmitter, and using equipment that would be far less sensitive as commercial-grade chips that would be developed for wide-scale market, we found that with 1 watt of power, we could cover 200-meter distances. And in fact, if you used antennas that combine the beams, you could actually cover distances of 450 meters, even in the non-line-of-sight, dense New York City environment. Since this work that we did at NYU Wireless, companies around the world have been conducting their own measurements and finding the same thing. This is very exciting to see that the industry is corroborating the results and starting to believe it. In fact, the companies demonstrating equipment today are all sponsors of NYU Wireless, and you'll see some of their prototype products that are the future of 5G millimeter wave. Just to give you an idea of how the wireless channel looks in the millimeter wave and how different it is to today's 4G cellular, you can see on the left a polar plot. This is what a receiver sees down on the street, like your cell phone, with a transmitter up on a base station 100 or 200 meters away. A scanning antenna can pick up energy arriving at different angular locations. We call these lobes. And in virtually every location that we measured, there are 2 to 5 lobes. So if you have an antenna that can steer directionally, electrically, to pick up these lobes, you actually can pick up a signal. And if someone walks in front of you in one of the lobes, the antenna could very quickly adapt and pick up energy on the other lobes. This spatial diversity is very important and will be a key to future millimeter wave. And surprisingly, the multipath. Multipath was a problem in first-generation cellular, and we've learned how to equalize it. We've used modulations to combat it. The multipath actually is comparable to today's cellular, which means that a lot of the technologies we use today for 4G could be applied to 5G, with the exception of the directional antenna needed. The fact that these channels are very directional is very important because it means new standards and new equipment will need to be developed to exploit this directionality of the millimeter wave channel. So we've been in the field for many, many years, conducted measurements that the world has needed, and I'm very excited to announce today that we're making available to the world, we believe, the first open source, publicly available channel modeling software suite that any academic, any company, any government agency or standard body could use. And we're actually providing a lot of our raw data that we measured in Manhattan, these time delay and angle spread measurements that can be used by anyone to verify the algorithms and hardware and software and the network architectures that will be needed to develop and make commercially viable 5G millimeter wave. You can download this software suite. It's open source, a very simple license. All you have to do is cite the NYU Wireless work and put a copyright sticker, and you can put it in products, internal, external development. This would not be possible without the support of the many companies and the National Science Foundation that have been funding this work over the last several years. But we make it available so that anyone can actually take the knowledge and the measurements that we've been doing and put it to work to engineer new solutions and new concepts that have to start with knowledge of the channel. So the renaissance of wireless, I like to call it the renaissance of wireless, is at hand, where wireless pervades everything we do and everything we wear and everything we're involved with. Wireless will be in the background everywhere. The fact is that the Internet of Things is coming. We see that millimeter wave spectrum not only can work, but it offers distinct advantages. It can allow great capacity and new applications we haven't thought of. And today we're offering this channel model software suite with measurements and a resource page with many publications and works that we've done, not just alone, but with companies like Qualcomm and Nokia and Intel and many of the people here today. So it's a very exciting time, an historic time, as the FCC works to put America in front of where we have to be, where the world has to be able to meet this insatiable demand for data. When you look at the revolutionary products and services that can be provided with data rates of several gigabits per second, They range from the driverless car to virtual reality. Remember the Star Wars movie where the little video comes out of the phone and is projected into the air? That's very bandwidth intensive, but we'll have those products very soon. There are prototypes that exist. These data rates will support it. Two-way medical applications that we haven't even dreamed of but are needed. The information shower. A student won't have to carry that heavy backpack into the lecture room. They'll just walk under the doorway and high data rate will beam down to their smart device and they'll have every textbook they need for the course. That's the future, the Internet of Things, as appliances and much denser devices are connected. So, in conclusion, we're entering the massively broadband era. The FCC, with its Spectrum Frontiers rulemaking, is leading the way. It's taken 40 years to just go up a factor of 3 in carrier frequency. Finally, we're going to go up to a factor of 30 and a factor of 60. And if we keep at it and we go up to the terahertz range, we can finally see that Moore's Law dividend come to wireless. By 2018, I predict we'll have 70 gigahertz carrier radios and 20 gigabit per second speeds working in the first 5G products. I hope they're here in the U.S. And millimeter wave is going to revolutionize the mobile industry like we've never seen. Think about this. If you think about 1 gigahertz carrier frequency, which is roughly where cellular started out, and you think about a 10% bandwidth allocation on that 1 gigahertz, that's 100 megahertz. And 100 megahertz of spectrum is about what all the cellular providers in the U.S. parceled up between them back in the 1980s and 1990s. If you go to 100 gigahertz and take 10% of that, that's 10 gigahertz. That's 1 with 10 zeros. That's orders of magnitude greater spectrum, wider pipes available to the wireless industry. That's what the Spectrum Frontiers begins to do. So with that, I say to zettabytes and beyond. Thank you very much.
So if we could have the panelists and the moderators for the first session come up, and I'll go over a couple of logistical things for today. My name's Cecilia Solhoff. I'm a press spokesperson and outreach coordinator for the Wireless Bureau. If you have any questions throughout the day, just kind of come find me and or one of the FCC staff, and we can help you out. So a couple of logistics. If you are here with your laptop, there is the FCC hotspot, and the password is all caps FCC 21234. The other thing is we are doing tech demos today. They're going to be open till 5 o'clock this afternoon. There will be a 2-hour break at lunchtime, so you'll have time to go visit the tech demos also. We are streaming this live on the web. So if you are watching remotely, you can do questions, send questions in for the panels by sending an email to livequestions, livequestions, @fcc.gov. If you're sitting here in the audience, we have some note cards and pens in the back. So if you could grab a note card or a pen, or I'll be walking around and I'll have some. And then if you've written your question down, just raise your hand, and myself or one of the FCC staff will collect it from you. Given time constraints and the volumes of questions that we receive, we'll try to answer as many questions as we possibly can during the day. The other thing is, as the moderators and panelists, as you're speaking, if you could please speak directly into the microphones. I know a lot of times you're talking to each other, but if you turn your head, it won't get picked up for the live stream as well as for the recorded video. So if you have any questions throughout the day, again, there's a program in the back. You can pick one of those up if you haven't already gotten it. So we're now going to begin with the first panel of the day, which is discussing Envision services, applications, and deployment of next-generation wireless technologies. We have 2 FCC moderators for this panel. The first is Brian Regan, who is an associate chief in the Wireless Telecommunications Bureau here at the FCC, and Steve Benzo, who is deputy chief of the Broadband Division, also in the Wireless Telecommunications Bureau. Thank you.
Okay. Thank you very much, Cecilia. Really appreciate it. Thank you, everyone, for coming today. Thanks to the chairman for excellent opening remarks, Commissioner O'Reilly for his remarks, and Dr. Rappaport for setting the stage for the discussion today. We've got a great panel lined up for you to start things off on the panel discussions. We're going to try to lay the conceptual groundwork for what next-generation wireless networks are going to be all about. Conceptually, we're going to try to expand the scope a little bit. We're not talking about defining what is or what isn't 5G. We're talking about the broader suite of technologies that will be enabled by the next generation of wireless. We'll dispense with the bios in the interest of time. You all have your programs. We obviously have a very talented lineup of folks here. We'll start off with some brief introductory remarks from each, and then we'll go into some question and answers. So we'll start first off with Asha Kennedy from Intel.
Slides will come up.
Should, yeah.
Thank you. It's really my pleasure to be here and with my fellow distinguished panelists so we can talk about this matter of national intelligence. Thank you. So as we go on, to borrow from NGMN, right, 5G is really about the connected, fully connected mobile intelligent society. I think each of those words is very important because what it alludes to is the socio-economic revolution that is going to impact everything in the way we live, in the way we relate to each other, the industries and all of it. ITUR, if you look at the triangle, I'm going to go to the three ends of the triangle, right, has three major categories of how this connected intelligent mobile society works. I'll start with the massive machine-type communications. This is billions of devices in an unprecedented range, right? Think about how agriculture will evolve, industries will evolve. You can look at soil temperatures, data, smart cities where we can control power efficiencies through lighting, through parking meters and all the way to how my health is measured, right, with nanotechnologies and how we look, how we live. So that's one angle. Another angle is the enhanced mobile broadband, right? Ted Rappaport actually talked a lot about this. I won't go into some of the details. But whenever we create more capabilities, we create more usages for them in ways we never envisioned, right? It's never stopped us. And the third one is ultra-reliable, low-latency communications. We're talking about 1 millisecond. This kind of latency is extremely important for applications like autonomous driving, drones, mission-critical applications, where you service things like power lines, disaster relief that may be too dangerous for people to actually engage. Even though I have described these usage models, I want to also add that there's a lot of usages that we have not envisioned because when we provide the technologies, right, there are things that people will do with them that we cannot imagine today. So as we move to what a 5G connected society looks like, we take a very end-to-end view of it. So far, right, a lot of it has been around how a person interacts with the device, right? Me with the phone, me with the laptop. But as we evolve, a lot of these connections and the interactions will happen between the devices. And the cloud will go from a cloud that stores data about people to a cloud that stores information about machines and how the machines will interact and what are some of the data. So to do this effectively, the network has to be transformed too. With the network transformation, you get intelligence where you need it. When you need it, you have to flatten the network. You have mobile edge computing. You have a lot of the efforts that are going on today. None of this would happen without spectrum. And so, we all know the importance of spectrum, and so we need every bit of spectrum we can get in whatever frequencies we can get to make this happen. Another point I would like to also make is that from a solution point of view, right, it is important to look at how the information passes to the edge, and hence we have issues around security and other areas and privacy. And so at Intel, at least, we are taking a very end-to-end centric view of this, and we are looking at all of these elements in how we solve the problem in bringing it to the future. 5G enablers. Given we are talking about so many different vertical markets, so many different use cases, we decided we needed a lot more experimentation in this technology. So we have a lot of prototypes efforts, both at higher frequencies and at lower frequencies. And at higher frequencies, we're looking at how we can enable these usage models. We have a lot of partnerships that we have announced, and we're working with many of the major operators around the world, and especially in the U.S. These prototypes and partnerships enable us to actually look at what is real and evolve and define these. I'd like to invite you to go to the demo area also and look at some of these. For example, one of them that I will point out is the Anchor Booster. The Anchor Booster demo is a little interesting, and it shows how when you go into a dense area, for example, the airport, right, you can still be anchored, right? It realizes you're in a dense area, you're still anchored on a low-range frequency, and then it puts you in maybe with a hotspot, like a 5G hotspot with high data rates, so you can download things and offload the wide area network. And then when you get up and go, you're back on the wide area network. So it talks about how it's very dynamic. So all of these then will feed into the standards process, which is ongoing. And then we have products, and as important as products is services, right? For example, if you have autonomous drones servicing icing on windmills and have safety implications both on humans and also on the ability of the service to continue. If you look at it from a timeline point of view, right, the initial mobile standards are around in the next release 15, with commercial mobile products that are standard specific in 2020 and beyond. Having said that, there's a lot of efforts where we'll have products from some of the major operators as early as a couple of years, like in 2017 and beyond, with different use cases. So we are both developing pre-commercial products and learning and going to the standards. As the demos show, a lot of this is happening now, and hence the time for us to act is now. If you look at even the sporting events schedule and some of the schedules announced internationally, we're talking about major trials in February of 2018. Just late last year, you saw with $45 billion, right, how much appetite there is. And when you have $1.3 trillion in 2019 on a use case that didn't really exist in this market a while ago, we're talking about a magnitude that is something that we have not faced before. 50 billion connected devices 2020. And the underlying need for all of this, as Chairman Wheeler called, is the mother's milk of spectrum, right? The U.S. has taken a lot of leadership in this area, and we're very grateful to Chairman Wheeler's comments to have us be continued leadership. And so I would like to close by saying that the time to act is now, and I'm grateful that we have this workshop right now so we can actually take advantage of it.
Thank you so much, Asha, for your comments. Next, we have Erwin Hudson, who's VP of Australia and Southeast Asia for Viasat.
Thank you. So my presentation is more kind of a historical perspective, and the kind of bring the satellite perspective to the discussion. Satellite's been operating in these millimeter wave bands for 15 plus years, and I think we feel like we're as innovative as 5G, the new 5G technologies. And if we could put up the first slide, I can. Thank you. Satellite really moved, commercial satellite really moved up into the millimeter wave band starting around 2000, in a big way. There were smaller activities, but people building dedicated satellites in a millimeter wave band with substantial capacity began around 2000. The very early satellites had about a gigabit of total capacity. So it's a $200 or $300 million investment in a satellite launch to get a gigabit. And over the last 15 years, we've invested literally hundreds and hundreds of millions of R&D to move satellite up into higher and higher capacities. It's pretty amazing that over 20 years, we've achieved about 1,000 times increase in satellite capacity. So right now, we're operating satellites with about 150 gigabits of capacity. Our Viasat-1 satellite and it's some heritage satellites that support it. And we have about 700,000 customers in the United States, and we're providing, I think, really high quality two-way internet service. We've got a second generation satellite that we're launching in kind of sometime next year, late next year. It has about 350 gigabits of capacity, and we have two additional satellites that are under construction that have over 1,000 gigabits of total capacity. So I think it's pretty dramatic, what we've been able to do in the same spectrum. And I think there's a belief amongst many people that somehow all the satellite customers are, in some extremely remote rural areas, some maybe the South Utah and some of the desert somewhere, but that's not the case at all. That the 700,000 customers we have, the customer density tends to follow population density almost exactly, even though the actual penetration of satellite in the remote areas is much higher than it is in the more urban areas. The absolute number of customers is actually much greater in the urban areas. We're not generally in downtown New York City, but you don't have to get very far out into the suburbs before satellite becomes a very compelling alternative to other services. As a matter of fact, we asked each of our new customers when they sign up for the service, what did you have before? And about 30% of our customers say that they switched from either DSL or cable. So we are truly competitive with those technologies. Our Viasat 3 satellite will deliver 100 megabit services in antennas smaller than 80 centimeters. It will enable full streaming, all the services that you would get with a fiber service. And we can do for enterprise and special applications, we can do gigabit connections to small terminals, including small mobile terminals. Another application of satellite is the mobile market in general. We're serving over 1,100 aircraft today. We offer 12 megabits to every seat on the plane on some of our customers. JetBlue, for example, they give the service away, and it works extremely well. Some of our airline partners now have made deals with service with content providers like Netflix and Amazon Prime, and you can stream those services at no extra charge on the planes, and the airlines love it. Bring your own content. You don't have to put all those little screens on the back of the seats and keep all that stuff working. Much better solution than trying to put the content on the plane before it takes off. But all this works, of course, just like we said. It's spectrum is the mother's milk of all wireless communications, and so we need access to spectrum. Our spectrum, we sort of look at it in two different ways. One is the spectrum that we use for our last mile, although our last mile is like 22,000 miles, but there's the last mile spectrum, and then there's the gateway or the connectivity spectrum, and you can do the math. It's real easy that in the early days when we had a satellite with 100 gigabits of capacity, and we could do 5, 6, 7 gigabits into an earth station, we needed like 15 or 20 earth stations, and we could put those out in remote areas and dig trenches and run fiber out to them, and that seemed to work okay. But once we go to terabit satellites, even if we can do 10 gigs, with the most advanced modulation you can imagine, it still takes hundreds of connections down to the terrestrial internet to bring all that bandwidth back down to Earth, and that is kind of the most challenging area for these next generation satellite designs. And so we've compacted these terminals now down from they're no longer big 13 meter or 7 meter antennas. They're more like 2-3 meter antennas, so we can place them much like a mobile phone tower. We can put them almost anywhere. We need to put them near fiber, and say there'll be hundreds and hundreds of these things, and they won't be strictly in remote areas. They'll be in suburban, but certainly won't be in downtown urban areas, but certainly be quite near urban areas. So our belief is these terminals are are highly directional. And have a well-controlled spectral mask. They generally point up, not horizontal, and so we're confident that if the 5G community and the satellite community work together, that we've got good engineering practices and design standards and just some easy rules to follow, that we can work well with 5G and share and coordinate, and I think we'll all be much better off.
Excellent. Thank you so much, everyone, for your presentation. Next, I'm pleased to welcome Dave Parrish, Manager of Wireless Systems at Google. Dave?
Thank you, and thanks again to the FCC for organizing this event. Let the slides come up here. So I work for the part of Google that is Google Access, and we're best known for Google Fiber. And one of the questions we get a lot is, well, why does Google care, or why is Google involved in access at all? And the way my boss explains it is, I think most people are familiar with Google's prominent position in what I'll call the Internet core and core services, Gmail, Maps, search, all of that. We also have a pretty big role on what I'll call the very edge. So we have Android, we have Chrome, and these businesses can only scale to the extent the pipe in between scales. And I think Google's acutely aware that the level of investment and innovation at the ends of the Internet is much larger than the level of investment and innovation in the middle, or at least that's our concern. And so we're trying to get involved and do what we can to move the access and the pipe in the middle ecosystem forward. You have slides? No? Oh, there you go. So, one of the things we're pretty acutely aware of is what we call the dynamic range problem in the Internet. So population densities, to start with, in the Earth go from many tens of thousands of people per square kilometer in an Asian urban core to remote parts of the world where there's only a handful of people. And yet we think it's very important to get connectivity where there is no connectivity and better connectivity where there is connectivity. I think Commissioner O'Reilly mentioned what I call the real estate problem. So we like to focus on cool technology for access, but really the starting point is, I say, three things: real estate, power, and backhaul. So you can envision all the cool modulation schemes you want and technologies you want, but you got to have somewhere to put your radios. So we envision that the world of the future is going to be, we're going to have to broaden the horizon, not narrow the horizon of all the places that we look, and eventually it's going to extend to people wearing base stations, cars with base stations, everything you can think of. Use cases, I don't know. Even today's world, I have to ask my kids, what's going on the Internet now? I thought about asking my granddaughter where we're going to be in 10 years, but she's not talking yet, so check back with me next year. So I have this title, The Heterogeneous Future. So we don't think that there's going to be one technology that solves all these problems. There's going to be an amalgamation of technologies that are all brought together using all these different platforms, providing a broad range of use cases. I think one thing we probably all agree on is again, this dynamic range is going to get broader. The high end is going to get higher. So if now people have tens or hundreds of megabits to their devices, we're going to go to gigabits, tens of gigabits, and the low end is going to get lower. We're going to have more devices that have very low bandwidths, but to do different things, like, how many beers do I have in my fridge? Okay, some people may need higher bandwidth to keep track of that, but these things are going to have to solve a whole different set of problems involving very low battery life, low power consumption. And finally, I would like to say Google is very encouraged by the proactive role the FCC is playing in recognizing that they've got to get out in front of this. And we do think a heterogeneous approach to the regulatory environment is appropriate to match up with the heterogeneous approach we're going to have to technology, to match up with the broad variety of applications and environments in which we're going to deploy all this stuff. So again, I don't know where the future is going. I think we all can agree on some certain trends. So we believe there's going to be this trend towards heterogeneity, And I do think that there's going to have to be a corresponding focus on seamlessness. So what users are not going to be very comfortable with is if we've got 10 different systems and 10 different technologies, if you have to spend all your spare time trying to figure out on your device how to connect up to the Wi-Fi versus the cellular system, these sort of things, that's not going to be interesting. So there's going to be a lot of work done in providing seamlessness. And this can happen a couple ways. One is coordination in the core, but the other thing is I think we're already seeing is client devices getting smarter and starting to make some of their own decisions. So Google's Project Fi, I think, exploits the ability of the client device to make decisions about where to use cellular and where to use Wi-Fi as an example. But the other bigger pieces are definitely just more, okay? More people connected, more data consumption, but as an engineer in the wireless space for many years, you make the observation that despite the exponential growth in data and data consumption, there has not been exponential growth in our ability to squeeze more data out of a skinny pipe, okay? In fact, we're already pretty close to the Shannon limit on most of our wireless links nowadays. We may get tens of percents. Maybe somebody comes up with something really cool, modulation and coding scheme, we get another factor of 2 out of a 10 megahertz channel, but we're not going to get a factor of 10 or a factor of 100. So there's really only 2 solutions that any of us see to that problem. The first is what we call densification, which means you basically make the area of coverage of a single wireless device smaller. So more Wi-Fi hotspots, you may even have several of them in your home. Base stations get smaller. We have small cells, picocells, femtocells, all of that. The problem with densification is it's expensive. All of those devices need to go somewhere. They need, again, the real estate problem. They need power, and they need to be connected to the internet in any case. So it really brings us down to the only hope, really, which is spectrum, which is why we're all here. And if you study Shannon's limit, it's pretty simple. There's a law of diminishing returns as you get stronger, better signals, but capacity scales with spectrum. If you have more spectrum, you can push through more bits. It's that simple. And so, the bad news is there isn't much spectrum down in the lower bands. Let's be honest. If there by some miracle were tens of gigahertz available between 1 and 2 gigahertz, that would be great, and all of our jobs would be a lot easier. But as Dr. Rappaport said, there isn't. And so the bottom line is millimeter wave is going to be where it's at because it's where the spectrum is at. And I think we all know there's pluses and minuses. So, the first minus I have is line of sight-ish. And the ish there is because I didn't have enough room on the slide for Rappaport, because I think everybody who's familiar with Dr. Rappaport's work knows that he's done a great deal of work to show that you can actually do non-line of sight millimeter wave work by harvesting the energy from reflections off the environment. The hard things that I don't think are going to go away are things like sensitivity to rain, walls. So it just is true that the penetration loss for most building materials is high at these frequencies. Windows depends on whether they're tinted or not. Foliage is a challenge, but it's finite. You can get through foliage with enough power. Oxygen, but only in the 60 gigahertz band. Anyway, bottom line is you're going to need directional antennas. There are some pluses. So one is all of these effects of walls and foliage and rain and whatever provides some natural interference control, which means that some of these millimeter wave bands will be well suited to unlicensed or lightly licensed approaches. So you'll see that I have range as both a plus and a minus. And Dr. Rappaport already mentioned this. I'm going to go into just a little bit more detail talking about the Frisch equation. So the reason that millimeter waves got this kind of bad rap as being poor from a propagation standpoint is most people look at cellular type systems using the left-hand side of the Frisch equation here, where you assume that the gain of antennas is preserved as you go from one frequency to another. Well, what happens is if you think about a simple dipole antenna, which we used to use for wireless base stations, at a 1 gigahertz frequency, it might be 10 centimeters long or something like that. If you scale that up to 60 gigahertz, you have this teeny-weeny antenna that's a millimeter high, and so lo and behold, it's not very fair to ask it to do the same job as the 10 centimeter one. So if you preserve the gain of the antenna, then you end up with this expression you see where you're sensitive to frequency squared on the bottom, and things get very hard from a, quote, propagation point of view at the higher frequencies. On the other hand, and Dr. Rappaport mentioned this, I'm going to take it a little farther. If you preserve the two-dimensional area of an antenna, the effect is reversed. And if you have a point-to-point link with highly directional antennas on both ends, you actually do better to the square of the frequency. So the power goes up, the power over the link goes up with the square of the frequency. That doesn't solve there's no miracle for walls, foliage, rain, and this sort of thing. But in good line of sight environments, there's actually an advantage to higher frequency. I will say people may be familiar with Google's Project Loon. So a couple of weeks ago, we shoved a high-speed data rate well over 100 kilometers from balloon to balloon in a test flight, and this is using the power of an indoor Wi-Fi hotspot. Okay, so well under a watt of power, and yet we could go 100 kilometers. These are not big antennas. It's just that the math is with you. This was in the E band, so 70, 80 gigahertz. The math is with you. So, a quick summary. The pluses of millimeter waves. We have bountiful spectrum, and that's going to support a broad range of use cases. So, I think my message I'd like to leave people with is it's not like we're going to go invent a millimeter wave 5G system and it's going to be one thing. What's going to happen is the different millimeter wave bands are going to be used to build a wide variety of systems from 802.11ad, very short range, docking stations, broadcast high def to your TV in the living room, to balloon systems up at the edge of space. So I think, again, I'd like to thank the Commission for driving this thing forward, and it's going to be a very exciting time.
Great. Thank you so much, Dave, for your thoughts and the quick math lesson. Appreciate that. Next up, we have Joe Lepowski, who's the CTO of Starry.
Hi, all. I'm the CTO of Starry. Starry's relatively new, so I'm not going to. It's not like it's obvious to say who's Google or who's Verizon Wireless and stuff like that. So it's a little. Bear with us as we introduce ourselves to you a little bit. So, how do I? Put this. Good.
A little higher speed connection for the slides.
There we go. Slow speed connection. Right. We got Bluetooth here. So as we introduce ourselves. We relatively recently came out of stealth mode. We're actually a startup about a year and a half or so old, basically, and we had a large number of veterans, basically, and I don't want to go into our past. Basically, some of you are probably aware of it with Chet Kanoja and myself. But in any event, I want to introduce Starry Internet to you. In particular, what it is a method of delivering broadband access to the home. We're obviously very excited about 5G. We think it's great. We just want it a little sooner. Pretty excited about Professor Rappaport's work. It uses millimeter wave technologies. It's capable of delivering gigabit speeds, and we have a little ecosystem here I can show you, basically, if you look at that. It's very moderate deployment costs versus fixed wireline. There's three fundamental components here. I'll start all the way over on the right. We introduced, and it's not a commercial, so please, I'm not trying to ask you to go to Amazon and buy one of these things for me. But we introduced the Starry Station, which is a very transparent WAN-LAN access point and IoT device. So what it allows you to do is it has very enterprise-like features, as well as effectively giving you health reports on how well Verizon, for example, might be providing you your internet. Essentially, it covers your features over time, that sort of thing, so that a consumer can see whether or not they're actually receiving the values that they've actually paid for. It provides smart home management, and it's got very basic Zigbee and BLE and Bluetooth Classic, that kind of thing, features, and we think it's going to be pretty interesting. It's got great Wi-Fi properties. It turns out the chipsets are pretty good these days, and it's all exciting. Going over to the left side of that, there's something called Starry Point and Starry Beam. Starry Beam being the infrastructure component, it's a relatively small component, about 2 feet. We obviously will shrink it down as time goes on, basically. Looks a little bit like a small version of a LTE RRH. And features, everyone's been talking about millimeter wave active phased arrays, and yep, it has one of those. It has a number of those actually in them, it turns out. And it has, uses hybrid MIMO, which is obviously seems like it's very, I wouldn't say it's stock or standard, but that seems like the way that most folks are going in this space actually, and it uses that, of course. It also incorporates integrated backhaul to solve that problem that's already been brought up, that you've got to actually connect a number of these things, and it depends how far apart they are, it can be more and more obnoxious to connect those due to real estate. Starry Point is a consumer installable access point, and so it's designed to have the same installation model as a air conditioner. We think most consumers are capable of installing an air conditioner. It's fairly sure that some won't wish to do so. However, we think that's a pretty desirable feature base that people like. It provides high rates of service, and it's safe. You can stand next to it. And one of the things that we didn't talk about today, we talked about lots and lots of power, et cetera, basically, but there is a limit, fundamentally. You have a safety limit to consider. You can't fundamentally burn someone's retinas, essentially, out, right, and you've got to be, I mean, honestly, there's a limit. Birds can't fall from the sky, and you can't burn someone's retina, so there's a limit you can have, and someone has to be able to stand by this device and paint their house while they're doing it, essentially. So. The full picture of the Starry Internet is, maybe it's a little small picture, but I do apologize for that. But we're using traditional assets, but also looking to governmental agencies, a variety of governmental agencies, not FCC, not federal related, basically, but more local related agencies are kind of disappointed with their coverage, basically, of their gigabit coverage, basically, for their consumers. So we're working with those kind of folks, basically, and we'll deploy these with Starry Points. And then you can see inside the home there's there's an ecosystem of the Starry Station and something called Wing, which is an extender which provides coverage inside the home, which effectively everyone wants to know how well their internet really works. No one really cares exactly where the problem is, but they only care at their handheld or at their laptop or at hopefully their Fire TV or their Chromecast or whatever, essentially. So that's really what's important, and we try to work that through as a total. So what are the innovations? And fundamentally, we're using 802.11ac based 5 gigabits per second stuff, basically, with MIMO, essentially about 15 gigabits per site that we're building in. So we expect a transition. That's again the standard for 802.11ac has been out since 2013. We expect a standard for 802.11ax sometime in 2016. Presumably, we'll transition hardware-wise in mid-2017 if that all proceeds in an orderly fashion. It may not, but that's obviously very much upon us, and we'll see those increases very significantly. Larger numbers of beams, et cetera, basically being incorporated in AX. Typically, folks are talking about 8x8 with 8 streams in those chipsets. We use 160 megahertz chipsets, so typically we tend to run a couple hundred megahertz, looking for a couple hundred megahertz channel, 37 gigahertz. And ranges we can see are probably up to about we're looking for a little longer ranges. I think I'd call them near line of sight ranges, essentially, of about 1.5 kilometers. Professor Rappaport's work is certainly very inspirational here as well, but seeing seeing the same kinds of effects that Professor Rappaport's has certainly observed. And again, the MIMO that's already built into 11.11 is quite handy for us. So the last innovation is that self-install subscriber units. I don't, not to insult anyone in the cable company here, but I can't think of anybody who'd want to give up a day for a cable install or an install, basically, if they don't have to. Particularly those folks who are innovative and really just want basic, what I would call gigabit dial tone essentially, and not try to have a cable TV service effectively. So I think that's hopefully an exciting offering. And for our offering, basically, we will include the Starry station so that consumers can in fact report if they don't like our service actually to ourselves very conveniently. So. Lots of parallels and opportunities with 5G. So I think we're a little bit of a precursor. I think there'll be some learning for sure. We're very much excited about 5G. We expect it to create and really connect hundreds of billions of devices. I've seen numbers which would account for something like 1,000 devices per person on the Earth, which is pretty amazing actually. I suppose that's possible. It's a big number actually though. Very excited about seeing a lot of discussion in the community how there's a mix of sub-6 gigahertz and millimeter wave, which feels very natural. I think we've heard before how difficult it is to penetrate houses and buildings and such, and you saw that our unit was an indoor-outdoor unit essentially to accommodate that. Where we see opportunities, I think, for us, we see that there's a lot of similarities between what 5G is trying to do and what the data networking community, or the wireless data network community in .11ac and .11ax has kind of already done. And I think there's additional opportunities for IoT. So there might be some learning in there for the overall community. We hope that there's some good learning that occurs, basically, because frankly, would seem to be like, we talked about the numbers and the amount of transfer, and we all look around for a Wi-Fi hotspot when we come into a place. So these folks have already spent thousands of engineering years in a kind of what I'd call I describe. There was a book I think called The Cathedral and the Bazaar, and I think it kind of said that the bazaar almost always wins. And I think those of you are familiar with that book actually. And I think that really the notion is having a bunch of little things that people are working on is really extraordinarily powerful, as opposed to a centrally driven approach. And lastly, basically, I think we don't have any. We don't understand we don't see that our technology that we've been working on is mobility related, and there's lots of issues with bands and such like that. But we're very much looking forward to what 5G can offer, and very appreciative of the Commission.
Great, thank you so much, Joe. Really appreciate it. And last but certainly not least, pleased to welcome Sandhya Shamsunder, who's the Director of Wireless Technology for Verizon Wireless.
Thank you. Thanks, Brian, and happy to be here. And the slides, okay. So we at Verizon have started on this 5G journey. 5G, I guess we may debate that, but we can call even 4G was debated. So I can call my technology 5G or our technology 5G today. So if you look at historically how we have evolved from 2G to 3G to 4G to 5G, I think roughly it's an 6 to 8 to 10 year cycle that these technologies, we spend time in those technologies, and they go through peaks, obviously. And we believe we are at the peak of 4G. In fact, maybe 4G peaked or exceeded 3G sometime in 2015 globally, as the Cisco VNI report says. And we launched 4G. We at Verizon Wireless launched 4G in 2010. That was about 6 years ago. And more importantly, the technology that behind 5G that many of our partners are already developing and have been developing in their labs is ready to come out into meaningful field testing, and that's where we are at the cusp of that 4G 5G transition. So what is 5G? So this is, we call it the rainbow of opportunities, and for some people, the low latency aspect of 5G seems very, very attractive. For some others, the promise of connecting billions and gazillions or maybe zetabillions, TED of devices sounds promising and is very attractive. But most importantly, obviously, the promise of bringing gigabits of connectivity is one of the most important aspects of 5G. And IoT type applications are being supported today in 4G. Nevertheless, I mean, latency is a challenge. We are continuing to improve with all our, with the industry in general, improving the the battery life of such devices that are required in IoT, improving the performance within the limits of 4G. We have Cat1 devices, Cat-M devices, the narrowband LTE. All those will fuel the IoT applications and revolutions. Even you'll see them soon, and they're doing it today, and they'll continue to do that. Nevertheless, we can certainly improve on what 4G is doing today by improving the latency as well as improving on the signaling technology itself. That will significantly reduce the battery requirements for such devices. So that's where the IoT applications come in. However, the wide bandwidth, as we said, and as mentioned earlier, if there was 10 gigahertz of bandwidth between 1 and 5 gigahertz, we could all use it. But we know that that's not going to happen. So the wide bandwidth aspects are tied to higher frequencies, and higher frequencies are what we call millimeter waves today. So that's where the capacity will come from for such networks. So nevertheless, there are several building blocks apart from the spectrum that make up the network, obviously, and many of those technologies are already in flight today in our network. For example, virtualization. Virtualization is a key aspect that will help scale. It will help scale the network for different applications. That helps the support of diverse applications, such as video, high throughput video at the high end, and metering devices with very small data packets at the low end. We want to be able to serve all those devices effectively and seamlessly and with the same scale. So we are virtualizing the network today. That is going to be foundational for 5G, obviously. Densification is happening today, and that is again a foundational technology for 5G in our opinion. Multi-RAT connectivity. Obviously, we have devices today that connect to all different frequencies and all different technologies. That is going to continue, and it's going to be important to have millimeter wave being supported in these devices as well. And finally, other technologies that enable millimeter wave to serve effectively wirelessly, as Ted mentioned earlier, and many of our panelists have also touched upon, is the ability to have a very large number of antennas, massive, what the industry calls massive MIMO. And some of it, frankly, has been around for many years, right? We in academia and industry have studied this for several years, but it's feasible now because of the massive integration at the silicon level that is possible, and we believe that is going to be one of the fundamental attributes of using these frequencies effectively. So. So to spearhead this, obviously we're not going to do it alone. We have our partners that we've been working with for many years, and we formed the 5G Technology Forum that will bring innovations into this technology essentially, as well as bringing new companies through our venture partners that are part of this forum, right? We are going to be working with our established partners, the large suppliers of the industry, as well as potentially new partners that would build the ecosystem around 5G for us. So looking forward to an exciting future on millimeter wave and 5G. Thank you. That's all I have.
Well, I want to thank all the panelists there for some very informative and insightful presentations. I'd like to take things back and do a couple questions, kind of let everybody give their input on a couple aspects of it. In terms of the impacts on business, and specifically certain verticals like manufacturing and transportation and healthcare. Some of you touched on some of these things. What do you see as the impacts of the next generation networks and the opportunities that they're going to provide for those industries?
So I think it's going to be foundational. For example, if I look at historically, 2G was so much about voice, right? 3G started the data revolution, 4G transformed the data revolution, and we started going into different verticals. When we go towards a fully connected intelligent society, right, whether it's like a beer manufacturer in Portland that requires all the sensors to know what capabilities he has and to adjust to it, or like Super Bowl, right? You know, when the kegs run out, it makes a difference on how fast you fill it. To agriculture, or even my sister who's a housewife with kids, right? What are her kids up to, right? What is the temperature of the house? What's the safety? It becomes so foundational because we're commoditizing intelligence, and it becomes like a necessity where without which, you know, like in the past, we had the internet divide, right? Without a good 5G accessible to all, it becomes like the difference between whether you can make it and whether you can't.
Yeah, I think satellite can provide the same services in the areas that the wired services find somewhat uneconomic to reach, as well as difficult to reach. With our Viasat 3 satellite, you'll be able to get somewhere between 100 megs and a gigabit, pretty much anywhere on the face of the earth, and you can buy services for $50 to $100, which, and of course you can use local 5G technology or local Wi-Fi technology to distribute those in the the most remote and isolated parts of the world. And I think I agree that that it'll fundamentally change the way that we deal with data. It'll fundamentally change the way that we medicate ourselves and educate ourselves, and the way society just deals with each other.
Yeah, it'll be interesting. Obviously, it's going to be very vertical dependent. Like I like to say, medical. My wife has a medical business. They're still trying to figure out how to use a computer. About 30 years behind the rest of us. But let me just guess that when we look back in 10 years, the industry that's going to be impacted the most, or the business, is the one that doesn't exist yet. It's going to be the one that we haven't imagined, just like 10 years ago we wouldn't imagine that YouTube and Netflix would be consuming whatever they do, 60% or something of internet traffic. So it'll be fun to see what it is.
Yeah, I think I would echo that a little bit. I would kind of call it kind of a kind of ever-present or omniscient, omnipresent gigabit dial tone, and I think you just really can't estimate what those could be. It's almost nearly impossible. Who would have thought you could, just make, voice calls would be much better on non-voice carrier services today. Wouldn't have been obvious 10 years ago. No one would have guessed. Everyone said, I'll use, use my cell carrier stuff. But that's clearly the worst choice, to be honest, today, quality-wise.
There's a lot of exciting applications, actually, that in the near term that seem feasible. Obviously, in the long term, the crystal ball is as good as anybody else's. But one of the things that is very exciting is the concept of the ultra-connected car. That is feasible with very low latencies. Not necessarily dependent on proximity sensors and stuff like that. Could essentially unleash that application to look very different than it is envisioned. The other one is robotic surgery. Is obviously, all these things come with their own business cases and things like that in the industry, but these are possible. And one exciting application that really is I think meaningful and makes it real is the connected robot, the fully connected robot. I mean, you can essentially build a low-cost robot and have all the intelligence in the cloud, and if the latencies are low and the bandwidths are high, you could have a very smart robot at a very low cost, potentially. That could fuel different industries, different applications. So exciting applications are possible.
Yes.
Okay. So we hear that there's these very diverse applications that are envisioned with 5G, like Internet of Things, where there's billions of devices, low bandwidth, and also different requirements for latency as compared to really high bandwidth applications, having both of those types of applications in the same network sort of drive different architectures, and what are the challenges there in terms of meeting both of those requirements?
So it's a good question, and I think that's where a lot of the technologies and the trials and all come in. The way we envision it, right, is it's not an either-or. And if you look at it, LTE was designed for something else, and yet we were able to make it work, including for the Internet of Things. And with 5G, we have an opportunity, especially by the time we get to release 16, to look at how can we have a unified air interface across all these things, so that when you look at you can get bandwidth, you can give it away, you can dynamically repurpose the network and repurpose the air interface to adapt to these priorities. I can't, since I'm from Intel, before I wrap up, I have to make a plug for Moore's Law again that Ted Rappaport did, and also say that, when you start bringing these into commodities and small scales, it really unleashes a whole bunch of capabilities. And to your point, by designing for these different applications in mind, we can design the things in a very different way that is actually assumes that this will happen versus designing for something else and then backtracking to it.
I guess my belief is I don't think we know yet exactly how the Internet of Things is really going to affect the Internet. I guess the way I see it is, in effect, all this new connectivity, we're sort of, we sort of took. We took all this capability and we put it up in the cloud, and now we're sort of bringing the cloud back down to earth like fog, right? Just sticking it down on the ground, and so everything hooks to everything and everything communicates with everything, and I think there's the obvious that instead of, certainly from an ISP perspective, instead of having a handful of devices with lots of bandwidth each, we're going to have a mix of devices that consume massive amounts of bandwidth, but we're also going to have millions and millions of little devices that consume very little bandwidth, and how to deal with back office issues like authentication and connect, acquisition, and it's going to be quite dramatic, and I think we sort of know the path forward. I don't think we know the destination yet.
Yeah, I would just say briefly, I think it's going to put a lot of pressure on us to get routing and QoS right, because latency is going to be key for certain things and less important for others. And so being able to prioritize the data streams that really do need to be low latency ahead of the ones that don't is going to be hard and important.
I think I would say that there may be more burden on even the IoT device and sensor provider. So I think there's a mix of burden to bear by both the 5G standard and the IoT. And in my example there is that nobody would ever have thought that Wi-Fi would be a multi-year battery kind of approach, basically. Yet I used an example of a product like Amazon's Dash, which is completely battery powered, and you just put it up there and it runs on Wi-Fi, and it's fundamentally doesn't use any power, essentially.
Yeah, I don't know if I want to add anything else, but I think they've covered the points well. The networks today are being built to essentially support different applications, and network slicing and virtualization type of technologies do enable that. And on the device side, there are a variety of devices of different types supported on the same network. So I don't believe that that's something that we can't handle in the future as well, only improve.
Great. So I want to build on something that Ashu mentioned, and I think was raised in the context of what does this mean for various other business verticals. So I think Ashu just mentioned the idea that you can build in from the beginning and try to anticipate what other verticals may need in the development process instead of seeing what they might need in the end and trying to build backwards from there. How do we bring those folks to the table to help now influence the decisions that everyone's making on the technology side, on the development of the technology, on the regulatory side, so that it's not 15 years later and healthcare is saying, hey, wait a second, we want access to the spectrum, or we want these services that are enabled. What's the way that we can now engage in that conversation to actually get those requirements built in the front?
I think start by accelerating the spectrum release, which we're all doing, so that it becomes real. And then, because it's very hard to do it's a chicken and egg problem, right? And then once we do that, we have very different models, right? We've worked a lot, millimeter wave, we've worked for many years, including on 802.11 AD and its evolution and all. And once we can have these trials and products, and as Sangeeta was also saying, Many of it is ready now, and when we start unleashing it, the innovation happens, right? Uber didn't exist a few years ago, and so just getting the spectrum, unleashing it, will naturally evolve it, especially towards businesses that are more contained, and then when you start experimenting in licensing schemes, they may be able to do things like in their factory and all.
I would just say, I think it's a hard problem, and the reality is we're not going to do it very well, and the solution is to maintain, and I think you guys have already hit on this in the end, maintain some flexibility and figure that we're going to iterate and see, get something out there, and as things improve, and they already are. I mean, people are already producing high-quality services, so keep our eye on the ball of what's flourishing from that environment and move in that direction.
I think I'd like to add that I think maybe the key from regulatory is have a mix of licensed, strongly licensed and unlicensed, and the full blend, the full spectrum of opportunities within that would be very beneficial, because I think it's just too difficult to anticipate what the future will be. But I think you do it the best by essentially allowing that bazaar to exist.
Yeah. I think essentially a lot of the industries are involved in the description of the use cases going into some of these technologies. So it's impossible to foresee all applications. Obviously, that's never going to happen. All the use cases, but to whatever extent we can, looking at the future requirements from a different verticals perspective, that discussion is already happening in the industry.
Excellent.
So, David, you already touched on some of this, the advantages and disadvantages of millimeter wave spectrum and some of the challenges in implementing. Take that into consideration. I wonder if others have thoughts on those and how that affects the architecture of 5G networks, and also what impact that has on other spectrum in the lower bands and how that might be used in the network in concert or collaboratively with the other frequency bands in the millimeter waves.
Some others go first and I'll add later.
Personally, I think that it needs to be a combination of spectrum. I think one of the things that's fairly clear, I think, is that these are not necessarily technologies that are as easy to apply for rural areas, and they may need to be solved, again, associated with satellite or with some other techniques or combination of techniques and bands essentially that occur. You've seen kind of a tension between various folks in the spectrum area and somewhat to the digital divide essentially not being closed for rural areas, for example.
So let's conclude with a question for context. So the transition in wireless technologies to date has been relatively tangible to consumers. They know that as Wi-Fi improves, their throughput increases. They know as you move from 3G to 4G, they're getting higher bandwidth, higher data rates. What does the transition to next generation technologies mean for consumers? How can we contextualize all the things we're talking about here in a way that is tangible to the consumers in the United States and across the world? And you don't have to go first.
Okay, go ahead.
I think the rainbow of app services and applications that I showed is probably a good example. It's connectivity where you want, and as wide a bandwidth as feasible based on the spectrum and Fat5, and then things faster, moving faster, and the IoT applications are probably some of the things that becomes real for some of the for the consumers. Apart from, of course, the faster smartphones. I mean that is going to happen. that is always a real thing for the consumer.
I think we need to open up the box of experimentation that many of the panelists have alluded to, right? Even if we go look, there's a lot of things real today, right? We have the different antenna arrays that we talked about on display. And if we can show things in every facet of society, if we can bring it to the table, right? Agriculture, it's an important one. home. It's another important one. So I think the fastest way to make it real is twofold. One is to talk about the visual applications, but show it becoming real and bring that to the table and contextualize it, because a lot of things are already happening, including like on the different IoT things in LTE, but accelerating it because when we go back to the foundation of a fully connected mobile intelligent society, it's really about the commoditization of intelligence. And when we explain it that way, they can be a part of the solution of things we have not even imagined.
Yeah, I think we're going to get drugged there. I mean, wireless always, because of our constraints with the narrow pipes, we're always a little behind. So, we're seeing a huge explosion in gigabit Ethernet services to people's homes now. And I think that's going to be followed very shortly by a bunch of applications that people learn to be dependent upon and love that require that. And then there's going to be frustration of why doesn't my wireless experience deliver those things, and we're going to have to stay up.
I guess, again, my point's the gigabit dial tone is really the way.
5-year-olds are key because they're going to have expectations
Yeah, they just want it.
that we don't even imagine.
All right, great. All right, well, thank you all very much. I think we're out of time here. I think this has laid a really great conceptual bedrock on which the next panel is going to build. Talk a little bit more about the technology that's going to enable some of these future networks. Thank you all very much. Please give them a round of applause.
Thank you very much.
So we're going to take about a 5 or 10 minute break and let you guys get up and stretch a little bit. If you go out the doors and up the steps and then around the corner to the right, there is a little vending area where you could get water or soda. We're going to start back at 11 o'clock. Could people please start taking their seats, and we'll have the panelists come up? Michael, do we have everyone? Do we have everybody now? Okay, so we're going to get started with the second panel. So the second panel today will discuss enabling technologies of next generation wireless systems. So again, if you're sitting in the audience, there are some yellow note cards and pens, and I'll be walking around with them, and just grab a note card, write your question down, and then wave it up in the air, and I'll come get it from you. If you're watching live on the live stream on the web, and you just joined us, you can submit questions for the panelists by sending an email to livequestions, livequestions, @fcc.gov. And in case some people missed it, the pass key for the hotspot here is capital F, capital C, 21234. So we have two moderators for this panel as well from the FCC. The first moderator is Michael Ha. Michael is Deputy Chief of the Policy and Rules Division in the Office of Engineering and Technology. The second one is Jeff Goldthorpe. Jeff is an Associate Chief of the Public Safety and Homeland Security Bureau here at the FCC.
Thank you, Cecilia. Good morning, everyone. And I'd like to thank all of our panelists being here, and especially the companies providing demo systems, including Intel from the previous panel. I understand that the demo rooms are getting pretty hot, and I think we like the fiery excitement of a 5G today here at the Commission. This panel is designed to illustrate how technology can support the 5G visions from the previous panel. And Jeff will introduce the panelists.
Thanks, Mike. The way we'll do this is just to roll down the panel and ask each of you to spend a moment or two introducing yourselves. Matt, we'll start with you, and after you're finished introducing yourself, we'll just go straight to your prepared remarks or your presentation. And when you're finished, I'll go to the next speaker. Okay, Matt?
All right, thank you very much. Can you hear me? Okay. Hi, I'm Matt Grob, CTO of Qualcomm, and I'm delighted to be here to really talk about one of our favorite topics, one of my favorite topics, which is how we're going to make the performance of wireless networks dramatically better. And so we've got kind of an overview we want to share with you on many of the items that you've just heard about, but we want to give you some detail on that. So I got a couple of quick slides. Firstly, when we look at 5G overall, we view it as a unified design for all spectrum types and bands. We're very excited about millimeter wave. I'm going to talk a little bit in detail about that, but also the mid bands, the low bands. It's all part of the picture to provide new services and improved performance. We want long link budget, long coverage. The low bands have their place, the mid bands have their place. So we view not only a full ladder of bands, but also different regulatory paradigms, licensed and unlicensed, and semi-licensed in between, are all part of the picture here. We want to natively incorporate new technologies. If you look at this chart, you see, a complete collection of improvements and enhancements, many of which we've brought to 4G. You see multi-user MIMO, or massive MIMO. You see millimeter wave. You see V to X. Okay, so like on the bottom right, V to X, which is vehicle to vehicle in a peer-to-peer manner, vehicle to infrastructure, vehicle to pedestrian. You see multicast and peer-to-peer. These are all technologies that we've added to 4G LTE. You see the use of millimeter wave for backhaul. Now we're talking about millimeter wave for access. But instead of adding to 4G LTE partway through its life cycle like we've done, which has been a good thing, by the way, now we have an opportunity to start with a clean sheet and natively add these technologies, and we'll be able to get even more flexibility, different types of interoperation, and better performance. We're very excited about millimeter wave and completely share Dr. Rappaport's vision about opening up more spectrum, and as it's hard to get 5 gigahertz between 1 and 3. There's still, I think, some room to go for reuse and small radius and technologies related to that, but really we want to unlock the higher bands. So what is it going to take to enable that? We need technologies like beamforming. We need to be able to move data. We need processing and interfaces on devices to be able to go at those speeds. We need flexible deployment models. Even if you get 100 meters, a couple hundred meters line of sight, it still implies that there will be large numbers of base stations, and so it's important to have self-organizing technologies so that deployment costs can be reasonable. The industry has got work to do on RF components. We need to improve the efficiency of power amplifiers and receivers operating at these bands and these band widths. So while we're able to do that today, there's still a roadmap ahead of us to improve the performance and improve the battery life on those kinds of things. I always like to show a couple of test results and some real tangible examples. On the left, you can see an antenna structure from a 60 gigahertz design that we have. In a small space there are 32 antenna elements, and we're exploiting the mathematical properties that were shown earlier today. And in that, with a given amount of area there, we can put a lot of antennas, form a beam, get very high gain. So not only can we do that, but we must do that in order to form the channels. Both sides of the link need to be searching and being able to operate off reflections and scattering and whatnot to make this actually work. And the picture on the right is an example, and we invite you all to come see our demonstration where we actually have an end-to-end system, and we've been doing extensive testing on these principles and showing that, yes, in fact, it really can work. Now, to extend on that, there's a diagram on the left there. It's a little hard to see, but basically it's a picture, an outdoor test, where there's a direct path between a transmitter, which is on the top, and the receiver, which is in the middle. And there's also a reflected path that's going some distance and off a shopping mall and coming back. And that's to illustrate that, yes, in fact, this happens and it can be used. The one in the middle, I think, is one of my favorite ones. Just real simply, the little trace on the top is a channel response at about 3 gigahertz, and down below at roughly 30 gigahertz, actually 2.9 and 29. And the point from that is just to look and notice that the shape on the bottom is not simply an attenuated version of the shape on the top. It has different character to it. There's a spike there that comes from a reflection of a light pole. At a lower frequency, the wider waves just diffract around that. At the higher frequency, that object actually becomes a reflector, and you see a very different character. Again, on the picture on the right, we're showing real testing. You can see the van, in this case, the cart moving around, and there's a depiction of the different beams and reflections and how we can do handoffs, and we are actually making this work. So the technology aspects, I'm less worried about. It's going to take a little bit of time, again, to get the efficiency and the refinement, but we can look forward to a lot better performance in the future. Okay, and then final comments on this is the overall picture of the schedule and the roadmap. Now, we got to remember that 5G is going to have a lifetime in the field of 10 to 15 years, same as 4G, same as 3G. And it's very important to, in our view, that we establish a global standard that can allow large-scale deployment and the best economy for the operators with vendor selection, low cost, and scale. And that is why we follow the track shown there with 3GPP and release 15, 16, and so forth, and it has a certain timeline that allows for deployments in 2020. Now, we know that there is a lot of interest to go a little faster than that, and we're going to support that. We're participating, and we think that's a very good thing. But we do want to be mindful to not create too much fragmentation, and hopefully initial precursor designs will have a path to become back to the mainstream, because we think it's in the best interest of the industry to be able to achieve large scale and not have as much fragmentation. Think about the actual timeline here as my final comment. When 4G physical layer was designed more than 10 years ago, it was before the iPhone, it was before the smartphone revolution. And that design has carried us very well. Now, if we start 2020 or 2018, something on that order, and go 10 or 15 years, this is going to go and be in the field until 2030 or 2035. In that span, the smartphone will be 30 years old, the personal computer will be 50 years old. Will they even exist in that form, in that time frame? Maybe, but most likely there'll be innovative new form factors that we can't yet see, although you might get a sense that there'll be head-mounted displays and other types of interfaces. And we really want to have the flexibility, the bandwidth, the spectrum, all those pieces in place, so when those devices arrive, the industry can have a large scale, low cost, and meet the demand of that. Thank you.
Thanks, Matt. I'll turn it over next to Woojun Kim from Samsung. Woojun, if you would just take a few moments to introduce us to yourself.
Sure. I'm Woojun Kim. I'm the head of next generation products and business at Samsung Networks. And I'm very excited to be here and have a chance to discuss with you what we've been doing in millimeter wave and 5G systems. And we have a fully functional end-to-end system right now in the lab over there, so you can go over there. My personal view is always it's better to look at the real system than to talk too much on PowerPoint slides. But could I use that? Or I think. But just to start off, so I've just got a couple of slides, and I'd like to just go over some of the what we've done and the technology we've been exploring and implementing. So This obviously is a slide made by engineers. I've been talking with my marketing department about getting some better marketing material. But I think it gets the point across here, really. It's two things. The first thing is on the left, you can see that we have been concentrating on building a 28 millimeter system for the last sort of 5 years. We've been working on millimeter wave for the last 5 years and looking at the technologies because we wanted to start from, does it work? Can it really be a basis for a cellular system? And that had to be looked at from multiple angles. It's not, first of all, can you just really transmit data? Can you get higher speeds? Can it really be used as a mobile basis? Because a lot of questions we do get today is, okay, fine, you can do point-to-point. That's been done by a lot of microwave systems. But what we need is a cellular system where people can move around. Does that work? Can you get into the form factor? Can you meet the power requirements? And what we feel is that based on what we've done so far with the system, which is shown on the left here, and that we have the demo over there, we're pretty satisfied that it works. So at Samsung, we think we're now beyond the research stage to the actual development of products. And so if you look at left side, that right now, that is the base station and mobile, and they use 48, 64 antennas on the base station side. On the mobile side, we use 4x1 or 8x1 antennas. We're using 800 megahertz, almost a gigahertz of bandwidth at 28 gigahertz. And we're getting up to, we're getting up to right now 10 gigabps. We've gotten to more in the labs. It's really a question of how much MIMO you want to put in, et cetera, on top of it. But we're satisfied you can get the bit per hertz. But the next things we've been focusing on is really mobility and also can you make it small enough. So on the right, actually, what we're showing there is the early work we've been doing on 28 gigahertz RF and antenna systems for handsets. We recently at MWC we did announce that we've already done a 60 gigahertz implementation, and what we've done is we put it into a Android handset form factor, and it was demoed actually with DT and a number of other companies I think as well. And what we did was we really took a commercial Android handset, and in it we put in our 60 gigahertz millimeter wave RFIC modems, etc., and we were able to fit it in, and it didn't burn your hand when you started using it. Though, because it is running at 4 gigabps, forget the RF side. The packet processor by itself gets pretty hot because it's running at a very high rate, much higher rate than you would normally expect. But overall, as I think Matt also showed a 60 gigahertz chipset. I think the beauty of millimeter wave is you can fit a lot of antennas into that very small space. So if you look on the chart here, also you'll see that we've shown that with the 28 gigahertz, you can put in a lot of antennas. We've got, I think, 16 by 2 antennas inside that module itself right now. And because you can make it so small, you can fit into a handset size quite easily. The other aspect, as I was saying, that we've been focused on is mobility, and this was also recently announced at Mobile World Congress. But this is something we've been doing for quite a while. The first thing we concentrated on was, just from one cell, can a handset move around and maintain the data rates? And this was announced last year. We showed, I think we have it even on YouTube, where a car can go around 100 kilometers, around 60 miles per hour, and maintain on average 1.2 gigabps. So that was, we thought, a great proof that it can't, beam forming and selecting beams can work within one cell. Then the next question was, okay, for a mobile cellular system, what you need is handoff, which is really moving from one cell to another cell. That requires handsets to be able to sort of look at multiple cells, do beam forming, select beams from multiple cells. And what we show here on the picture here is we show the tests we've done at Suwon actually over the last year or two, where we have 3 base stations set up, and we have a van moving around. Due to the limitations there in the Swan City, our development park, we're not able to go over more than 20 kilometers, though we have had people suggest that we go 60 or 80 there at night, but it is a bit dangerous. But there we're able to go anywhere from about, on average, we're getting around 1.6, 1.7 gigabps in the van as the car is moving at 25 kilometers per hour between 3 or 4 base stations. And it's, again, it was a step-by-step progress. Up to this stage, it was still research. Does it work? And based on these factors, the basic system, can you get the speeds? Yes, we can. Can you get the millimeter wave chipset small enough that you can put it into handset? Yes, we can. Can you make mobility really work? Yes, we can. And so based on all of those things, we're now very satisfied with millimeter wave. You do have a basis on which you can build a cellular mobile system. Of course, we're not saying that you can build a nationwide 5G only based system. You will have, relations with 4G. You also have to start working on the sub-6. You have to work on the, the mid-6, whatever, spectrum for other uses. But I think the foundation of which we're all looking for, which is massive spectrum and millimeter wave bandwidth, does work. So the next slide is really just the work that's going on in the standards and what we're sort of pushing for. And as you can see, we have sub-6 and above 6 all work going on simultaneously. But as Matt was saying, there is a push in the industry to actually do things even faster than this. And we're very much supportive of this because we feel technologically it works. It's really now just getting everyone to agree on the specifics. So while we acknowledge that there are challenges in meeting the standards, timelines, and also implementing something commercial, if you look back really, I think it was what happened with LTE. While there was a lot of work beforehand, if you look back, in 2007, I think was when 2 big things happened, really. Though my company rule says I can't mention that company in Cupertino, one company at that time came out with their vision of what a smartphone or the next generation phone will be. And then also at that time, Verizon, I think, announced that they were going to do LTE. And I think if you look back, at that time, the reaction to the phone was, depending on who you were talking with, but there were a wide spectrum of people, and certain people were saying, that's nuts, that's never going to work. And also with Verizon's LTE announcement, a lot of people were saying, that's nuts, the standards aren't even fixed, it's not going to happen. But then if you roll back, and you roll forward, I guess, from that to 3 years later, 2010, LTE was rolled out, and that company in Cupertino was on the wave of a revolution that everyone else started following. I think if you look back here, we're at 2015, 2016. I think this year, if you look at MWC, there was big movements on multiple new things, but if you look at it, it's really, CS was basically taken over by cars. IoT, virtual reality were big things right now. And we've got a big push for 5G now, just starting. And again, it's very similar reactions. This is crazy, this is over pushing it. But then if you roll forward to 3 years, I do not want to be the one who's going to bet against something happening again. So, thank you.
Thanks, Woojun. Next, we have Paul Steinberg. Paul's from Motorola. Thanks for joining us, Paul.
Thanks, Jeff. As Jeff said, I'm Paul Steinberg, CTO at Motorola Solutions. And I'll take a slightly different slant on what we've been hearing so far this morning about gigabits per second and millimeter wave, and talk a little bit about how we're thinking about applying this for business and mission critical communication. So if I could have the slides, please. Thank you very much. So the world of first responders and the business and mission critical communication paradigm, the way they've communicated and collaborated for almost 50 years now has been by voice communication. And that's served us very well from the very first, I like to say, the handy-talkie is the very first portable mobile phone. If you could kill somebody with it if you swung it at them, but it's rather heavy. But the state of the art today, it really hasn't changed that much. It's much more complicated. But if you look all the way to the right, the transformation we're seeing with our customers is from communication to intelligence. And certainly the communication part is very important for that to all work. But that isn't the end goal anymore. The end goal and some of the hard job is actually getting that information on the ground in a usable way. So, complicated slide, as my colleague said, only an engineer could love this. But the basic point is that the services are really wrapped around the edge of this. And it's not, as was said in the previous panel, it's not about a network. It's about a plethora of networks. And the network that is best suited for the task at hand, and the suitability may be grade of service, it may be cost, it may be what gives the device the best battery life, should be used and applied. 5G is now the emerging technology, and back to a comment Matt made, it's an opportunity to start fresh and solve some problems that inherently the Gs have built up over time, and gives us an opportunity to set that platform. But the magic is around the edges here, and it's selecting the right network, selecting the greatest service that the network can provide, and then applying that to realize the applications. And the pattern that we see repeatedly, no matter what industry, is that of capture and bring data in at the edge, move it as rapidly and carefully as possible to some place where a decision could be made, and then turn it around and mobilize that data in whatever way with whatever modality makes the most sense. So we have an exponential curve as well, but I think everybody does. We've done a lot of modeling and tried to predict what we think first responders, in this case in the United States, usage of broadband will likely be, and we're at the early stages of what will truly be a mission-critical broadband network with the work that FirstNet is doing in the U.S. But as you can see, it's expected to grow dramatically, and what will drive that is not unlike what you would expect to see in the consumer world. Virtual presence, media sharing, telepresence, those become the key drivers. Those are the requirements for moving the bits. One of the interesting things about our users is they need to be able to go to places where it's very difficult or unsafe to be. So if we can put technology there but virtually place them there with the technology, that's a very powerful enabler. Critical communications obviously need to be secure, highly reliable, provide ubiquitous coverage, and as the graph on the right kind of depicts, that's an actual plot of a city in terms of a projected workload from a broadband point of view over the course of the day. The problem with public safety in particular is it's very difficult to impossible to predict where the loads will come from. Bad things don't always happen in the same places, and they don't always happen at a given time of the day. And oftentimes they need to project coverage in places where there are no networks, where it's not commercially reasonable to build networks. So deployable systems become very important, and we're spending a lot of our time thinking about that as well. And then finally, as I've mentioned before, it's hard to call something mission critical if it isn't reliable from a cybersecurity point of view. And I'm surprised we've gotten this far into the conference, and I don't think I've heard that word mentioned yet. So we're about to mention it a lot on the subsequent slides. I think my colleagues have talked about that. It's the same terminology we've heard before. What are the key ingredients that actually make this whole thing work? Densification certainly is a key component of that. Part of the densification component is software-defined network and network functional virtualization, or slicing the network. There's really nothing physical anymore. It seems like everything is virtual. Sometimes I wonder who's going to actually make the hardware. Everybody's just writing software. Spectrum sharing. I think it's not just a matter of having more spectrum. That's an important component, but it's being able to utilize the spectrum more efficiently. So dynamic spectrum access becomes very important for a couple of reasons. One is efficiency. Two is that gives you some agility if spectrum is being maliciously jammed, disrupted, or if for whatever reason it's just over capacity. So being able to dynamically select spectrum to pair with the network of choice. Certainly coverage and capacity. I think 5G provides tremendous opportunity to project coverage and capacity in very selectable and scalable ways. And then, as I mentioned before, security becomes a very, very important component of this network if it is to truly be mission critical. So under your own direction, Jeff, and then with the leadership of Admiral Simpson at the FCC, they foresaw some of this coming certainly early last year, and they commanded the Technological Advisory Council to actually start to look at two key topics that come to bear here. One is basically Internet of Things and cybersecurity implications of that, primarily from a consumer point of view. And we've now pivoted that work this year towards specifically Internet of Things as it juxtaposes with 5G. And we've talked a lot about that this morning. The other key component of this that we started last year is around software-defined networks and network function virtualization. And there's some pretty profound implications to both of those when one considers the security and the resiliency of the networks. So just to kind of run through some of the key considerations we see and what we're spending a lot of time working on in Motorola Solutions. So first is just protection of the dynamic spectrum enablers. I mean, obviously, if there's a dynamic spectrum control plane and that's not functioning, and the radio devices are expecting to be able to use that to acquire access to a network, that's a serious problem. So that's in effect a way of virtualizing the RF. Increasingly, the control plane of these networks is not encapsulated. It's actually shared. It's spread across multiple networks. That becomes a challenge as well. Privacy enablers. Obviously, these ephemeral kinds of little bits and pieces of information, such as IMSIs, being laying around out there, that becomes a significant issue for people that are trying to not necessarily identify themselves or be easily identified just because somebody grabs a hold of their RF link and queries them. Another big component of this, and this is going to be, we think, a big deal for IoT, is cryptographic agility. Right now, basically, I think in 4G you have two choices of cryptographic algorithms, and it's a very hierarchical network in terms of how it manages and distributes the keys. So it's a very symmetric key kind of oriented system. In a network where you have vastly differing kinds of devices with differing capabilities, different costs to deploy and manufacture, the ability to authenticate and authorize these devices in an efficient way, but one that actually scales to their capability becomes very important. So the ability to dynamically select crypto algorithms or allow certain applications to insert indigenous algorithms that make sense for their purposes. The decentralized trust models become very important for this thing to actually work and fly. As I mentioned before, the hierarchical system, which has served us so well now through a largely driven top-down model, probably don't stand themselves to scale very well in a world of billions and billions of things. And then finally on the right, I think if you think about the design of this network and as the standards bodies kind of work through that, the NIST cybersecurity framework, that is the model whereby cybersecurity is managed. It starts with making sure we build in the controls to identify threats all the way through to making sure that the network is resilient and can recover. Even in the RF space, today's networks are far too easy to jam, far too easy to disrupt with a DDoS attack, so thinking about those issues as well. So that's what we're thinking about in Motorola Solutions, and I wanted to interject the cybersecurity aspect of that and get rolling on that.
Thanks, Paul, and thanks for breaking the ice on the cybersecurity topic. Next up, we have Amitabh Ghosh from, and thank you for being here today. Okay.
Thank you, Michael and Jeff, and it is a great pleasure to come to this workshop, and thanks FCC for organizing the workshop. I am Amitabh Ghosh of Nokia. I'm a Nokia fellow and head of small cell research at Nokia Bell Labs. So, the slides.
That's a good slide.
Okay, so I'll talk about these three pillars of a triangle, which the other speakers and panelists have already talked. 5G is about massive broadband, supporting a peak rate of greater than 10 gigabits and cell edge rate of 100 megabits. The other half is ultra reliability and low latency communication, low latency of less than 1 millisecond for critical machine communication. And the third pillar is massive MTC, and you see that massive MTC is already supported by LTE, and 5G will enhance it. So we have narrowband IoT and LTE-M, and this massive MTC is already partially addressed by 4G. So 5G will also, as the other speakers have said, will address bands up to 100 gigahertz. So in 4G and 3G, the bands were restricted below 6 gigahertz. So 5G will address bands from 6 to 100 gigahertz and also below 6 gigahertz. And it will provide massive densification. That's one of the areas where you can improve the capacity of the system, and also using large spectrum from 6 to 100 gigahertz, large bandwidths. So the key is densification, and the technology to use, one of the main technology is massive beamforming and massive MIMO. So people have talked about the the schedule for 5G, and 3GPP is already addressing it. So we have started with the channel modeling and requirements, which is now going. And this 5G was initially driven by all the sports events in Asia. So the first phase of 5G, which will address bands up to 40 gigahertz, it will be completed by release 15 2018 timeframe, and the phase 2, which will address bands up to 100 gigahertz, will be completed by 2019 timeframe. So what are the major technologies of 5G? So here I include, say, 10 technologies. One of them, the first one, usage of centimeter wave and millimeter wave bands, so bands from 6 gigahertz to 100 gigahertz. The other major technology is UE agnostic MIMO and beamforming, and it will be, the next one is the lean carrier design, so we get rid of all the overhead channels in LTE, so we have a lean carrier design. The next one is the flexible frame structure. So we want a frame structure which will support this radio latency of less than 1 millisecond. And we are decreasing the radio latency by a factor of 10 when you go to 5G. The next important thing, which is the backhaul piece and the access piece, and we call it dynamic TDD, where each slot can be an uplink or a downlink, access link, and also a backhaul link. And this is a very important aspect of 5G. The next technology is enhanced interference coordination, which we have seen being introduced in 4G, and there will be enhancement to that. And also, the one thing I like to point out, that 5G will not be totally new. It will be a combination of LTE and where it will be using existing technology coupled with LTE with dual connectivity and sort of like that. Then the full duplex, the main application of full duplex is wireless backhaul, not for access. We lose capacity. We don't get that much of a capacity when you use full duplex for access communication. Flexible connectivity, mobility, and sessions, and new waveforms. We are still up to 40 gigahertz. We are looking at OFDM-based waveform. When you go to bands above 40 gigahertz, you will see single carrier modulation, although the uplink of LTE is already single carrier, but 5G in the 60 gigahertz above range will be single carrier modulation. So the next thing I like to add is that what are the 5G millimeter wave proof points, and what are the things which a 5G millimeter wave system for overcome. So the two of the main difficulties are the acquiring and tracking user devices within the coverage area of base station using a narrow beam antenna, and mitigating shadowing and with base station diversity and rapidly rerouting around the obstacles and user devices by an opaque obstacle if there is an opaque obstacle in its path. So we address this by using base station diversity and use of massive arrays so that we have real beamforming gain to compensate for the penetration and foliage loss. So the other aspect of the millimeter wave system which it should address is high peak rates and high edge rates, and which we do it by using very wide bandwidth. So in LTE we are using 20 megahertz, 40 megahertz, up to 100 megahertz with carrier aggregation, whereas in 5G we'll use up to 2 gigahertz of bandwidth, which will enable these huge edge rates and peak rates. One of the major technology is this millimeter wave RFIC, and this shows that the antenna should be and the transceiver should be integrated, and this is one of the cornerstone of the technology for 5G. I'll not go through the details. next slide is to show that Nokia is working on these proof points of 5G. We already have a demonstration of the system which we are showing, where we are showing how we can track a mobile using beam steering technology. We have also shown at MWC a 15 gigabit system using horn antennas with 64 QAM modulation using 2 gigahertz of bandwidth. So we are using a bandwidth of, it was in LTE 20 megahertz, now we are using 2 gigahertz of bandwidth, 100 times the bandwidth. So we are working on the proof points, and people were very skeptical when we started on 5G. With the millimeter wave especially, that what Ted pointed out. But now, millimeter wave is becoming one of the foundation of 5G. And you can show that we can cover in the line of sight environment with, at 73 gigahertz, we can cover up to 200 meters and above in the line of sight environment. So finally, that's all I have, and security was one of the important things, and because of the small cells, we need to have the security so that, and the security will be dependent upon what are the applications. And that's all, and Nokia is conducting research in 5G security aspects and is implementing various proof of concept. We are involved in various groups so that we can bring 5G to reality. That's all I have. Thank you.
Thanks, Amitava. Next we have Kumar Balachandra from Ericsson. Kumar?
Hi, I'm Kumar Balachandran. If we can have the slides. Thank you. I'm Kumar Balachandran. I work for Ericsson Research as a principal research engineer, and I will provide some idea about what Ericsson's 5G perspective is. Amitava has already spoken about the 3 pillars that 5G standardization is going to stand on, which is enhanced broadband, massive MTC, and mission-critical machine-type communications. What I will do actually is to elaborate a little bit more on what this actually implies in terms of what the system evolution is going to be. We're going to have a whole lot of new deployment options. There are new network deployment features like neutral hosts, where an enterprise, for instance, can deploy a network and attach to the existing telecom infrastructure. There's industrial process control that is being targeted by some of the applications, intelligent transportation, dense cells and very large antenna arrays are going to have to be deployed because of the frequency bands that we will have to work on. In terms of new tools that are being made available are virtualization, software-defined networking, distributed cloud architectures, and in terms of operational efficiency in the network, you will see that in a future slide I will have some information on how orchestration and control play a role, as well as a high degree of programmability in the network for rapid service deployment and so on. So if we look at the spectrum aspect of it, there is an evolution as well as a revolution story for 5G. We cannot, as I said before, one of the aspects of 5G is to provide extreme mobile broadband, very high data rates, and there we have a need for wider bandwidths. And that is one of the reasons why we are looking at higher frequency bands where wider bandwidth allocations are possible. At the same time, LTE will continue to evolve, and the new access interfaces, which we internally term as NX, will start migrating into lower bands as well. In this respect, I'd like to highlight what Commissioner Wheeler said in terms of there being a role for 5G in the high, mid, and low tier bands. And one of the changes that is already happening with massive machine type communications is the development of narrowband IoT and 3GPP. That will be a very strong component of 5G for machine communications and for IoT. So if we look at what's happening on the network side, there's a huge revolution happening in terms of the network. So far, mobile networks have been effectively walled gardens. We haven't enabled a whole lot of programmability or service flexibility in the network outside of providing basic pipes for communication. What is happening right now is are four different advances that are being made in the network architecture. One is the advent of virtualization, where high-level application services can be migrated way deep into the network, probably as close as possible to the air interface in many cases. Software-defined networking allows a separation of the control and the data planes in such a way that you have very standardized management and orchestration capabilities at the top level that can program individual components in the network quite effectively to enable services. The distributed cloud aspect allows for functionality to be deployed in various parts in the network and to be able to provision processing and compute and storage way into the network. And there are advances being made that allow the network resources to be sliced in such a way that you can isolate parts of the network away from on the basis of the service characteristics. So, for instance, applications like intelligence transportation can have its own slice in the network that will allow very specific quality of service and security and management constraints to be established for that particular service. Now, in terms of key NX technologies that we are looking at, this is for mobile broadband. We have already heard about all the changes that need to be implemented for bringing in millimeter waves. We are going to have site connectivity for very dense networks. Multiple antennas, including distributed MIMO, are going to be introduced. There's the separation of the data and the control plane. We have a philosophy of going in for very lean design for our control channels. So in past cellular systems, there has always been a common control plane that has been quite heavy in the amount of bandwidth that has been consumed. In the future, we are really looking towards separating out control and signaling in such a way that signaling is directed more on a per user basis, and it's being made more energy efficient in terms of network resources that are being used up. And then, of course, for connectivity, we are going to have to enable wireless backhaul. And here, one of the changes that probably needs to happen on the wireless backhaul side is to have a certain merging of the access and backhaul infrastructure to a large extent, where backhaul links now become more point to multi-point in nature. And you're able to use the same principles that are used to provide access to individual consumers towards providing backhaul connectivity as well. Expecting that we can draw fiber to every base station is not always practical. We will have to expand our perspective in terms of what we do for backhaul. And typically, in terms of the physical layer, we are looking more towards an OFDM-based architecture. This will be scalable so that we are able to scale the signal waveform as we go up in frequency. And Amita already talked about dynamic TDD and the role of single carrier modulations as you go higher up in frequency. So security is, of course, a very important topic. In general, we see four aspects that will affect the way security is architected for the 5G network. The changes that are happening are that there are going to have to be new business and trust models that the network allows. There are many phenomena happening today, even today, in the way we use our devices. For instance, the bring your own device aspect. If you look at car manufacturers, they might want to set up a management service for cars where you get information from an engine that is constantly being sent up to the network. You want to make sure that the quality of service requirements of a particular vertical application are maintained on the basis of business relationships between the application consumer and the network provider. There are, of course, increased privacy concerns as well, especially in Europe. There is a lot of focus on personal privacy. This is going to continue to be important. And there is an evolved threat landscape, especially when you're talking about introduction of IoT and devices of various different capabilities that will have limited and constrained ability to have very complex authentication features and so on. And we think that security can be enhanced by using the basic concept of network slicing, and security assurance models will have to evolve to be able to handle third-party applications and services in the network quite effectively. So the challenges, of course, are that there is going to be a lot of 5G that will pervade beyond the telecom industry. It will go into the industrial internet. So we will have to handle roaming between the telco domain and industry verticals. We have to account for third-party virtual network functions. And initially, of course, this will have to be a very collaborative process so that functions are implemented in the network and they are proved and they are integrated into some sort of a toolkit that can be properly chained into a valid service. But industry is very much in control of the security aspect. So over here, I have to emphasize that light touch regulation is very much in order. Finally, I have the slide on the time plan, but I think many of my fellow speakers have been quite eloquent on this, so I will turn over some time to Tyaga over here.
Thanks, Kumar. And then finally, we have Tyaga Nandagopa from the National Science Foundation. Tyaga?
Hi, everyone. Hello, everyone. I am Tyaga Nandagopal. I am a program manager in the Networking Technologies and Systems program at the National Science Foundation. Prior to coming to the National Science Foundation, I served about 10 years at Bell Labs in Murray Hill and Homedale. So my background is in wireless networks and also in software-defined networks. So one of the good things about being on a panel like this, having been on several of these, is you always want to go in the last because you can say fewer things, because most of the stuff you want to say in the technology stuff has been covered by others, and this is great. So let me talk about a different perspective, right? So from the technology aspects. So as a only member of the federal agency here at this panel, so we have a mission statement that we are actively working on at all times. So our goal, the NSF's goal, is to promote the progress of science and to advance the cause of national health, welfare, and prosperity, right? So that's our goal. And clearly, in pursuit of that mission, we invest extensively in all fields of science, and every technology that you have seen discussed here today are things that we have been exploring for at least for 5 years in the 5G domain. And of course, there are other things that we consider. I mean, the IoT, for example, which we call cyber-physical systems, have been at play in NSF for more than a decade now. So there's quite a bit of interesting work. And of course, Ted can attest. And thanks for thanking NSF for that, acknowledging us. And so we have supported a wide variety of researchers whose work has gone on as the foundations for many of this work here. Okay. Now, what is our vision of the future? Clearly, the way we see it, and I think this is obvious to most people here, but it's worth saying again that everything is in the cloud, and of course, everything will be accessed by the users and devices through wireless. Okay, so we are going to have this massive network of data centers, and that are going to be pervading, holding all the information, and of course, we are going to have access through a high-capacity wireless skin, right? And this skin, of course, it can be multi-layer stick. It can be wireless backhaul. It can be last hop wireless, right? It can be satellites. It can be long-range wireless, low bandwidth IoT stuff. So it can be anything. But it's all, the bottom line is we are going to forget that we ever had wires, right? Our kids, I mean, my kids don't know what a wired network is. They don't understand the notion of a laptop having to stay at a desk, right? So this is the future we are heading to, and clearly we are all in alignment on that. Now, what is our goals? We don't call it 5G, right? We think of 5G as a very limited stop in the way to a much more pervasive wireless future. Our goal essentially is to ensure research continues on, and we seed disruptive innovation. So we see ourselves as a venture capitalists of research. Okay, so we invest all over the place with the hope that a few things become great breakout hits, right? Of course, everything else also has some payoffs in the long run by encouraging university-industry cooperation, as well as by training the next generation workforce. Again, pretty much everybody here is aware of if you had a PhD, you are probably funded through NSF grant, right? And of course, so the other ways in which we want to help is by participating in such visioning exercises to identify emerging themes. So when I am here, I'm not talking as NSF about NSF as a person in my individual capacity or NSF as an organization. We are the collective voice of the research community. So all of these perspectives that I'm sharing with you is what we hear. We are in a constant feedback loop with our community of researchers, not just academic, but also industry. Right? And we have them on our panels, review panels, and workshops. So this is our longer scale goal to continue this interaction and enable the cutting edge research that you all want to happen. And of course, part of the challenge of all of this is, we as researchers would like to test things at larger scales. So, we have seen demos at Mobile World Congress, nice one car rolling around in a neighborhood. You show a proof of concept. This is great. how do we get to the next step? Clearly, no single company has the ability to put together, get a city involved, right? It's much more work for them. And there are other ways in which this can happen, but NSF has had a lot of success through initiatives such as US Ignite or Genie and similar infrastructure initiatives where we have put together a consortium of partners that can act together and create this large-scale test infrastructures. And we see that as a very critical piece in the 5G debate, where companies themselves are not very sure what is the killer app. Right? The killer app debate is essentially one that drove 4G, and the iPhone solved the problem for a lot of them. But in the 5G space, I see that similar concerns come about. Given how broad 5G is, it's a significant concern. And we hope that creation of some large-scale national infrastructures would help address this confusion as to what could be the big one. So within NSF, we have a large array of programs. I'm not going to talk about those, but you can read them. We address the systems, the devices, the theory behind things, as well as we have several cross-cutting programs. For example, the radio spectrum sharing is focused entirely through a program called EARS. So we have addressed a lot of dynamic sharing related problems. We have a large-scale program that has been going on for about 6 years now called Future Internet Architectures. So this is essentially re-envisioning how would you design the internet if you had to do it today with a clean slate, knowing all the things that could have been done better. Right? So this has been happening for about 6 years, and we have great results out there. I'm going to speak about a few. So cumulatively, all of these programs, and just focusing on the wireless and the related networking interfaces, we have invested about close to $100 million per year over the last, I would say, the decade. Okay, this is a sizable amount, and this covers researchers in all major U.S. institutions. And again, many of you are probably here as a result of some of the work we have done before. So I'm going to cover a wide array of programs that here. There are several more. I mean, I'm not going to do justice to any one of them, so my apologies to anyone watching here. Please don't be offended if your project is not here. This is just a sample given the limited time we have. We have a list of comprehensive links to all of these at the link noted in the slide. Now, the first one I'm going to focus on is the named data networking. So this is a future internet architecture project. Essentially, we challenged our community to come about with a way, what would you do if you had to rethink the design of internet? And one of the interesting projects said that, well, what is the networks for? Right? They're not there for protocols. They're not there to take data from one place to another. It's about conveying information. Right? So what if we re-engineer the networks from the notion that if all you have to worry about is how to get information from point A to point B? Right? So who has to be named? It's the information that needs to be named, not the endpoints that need to be named. So we all know that TCP/IP has its infinite limitations with respect to mobility due to the restrictions of tying endpoints to addresses. So this project has come up with a very interesting architecture. And again, this is a very large-scale collaborative project with 10 institutions. So this has gone about 6 years now. We have a public code release happening next month. So this code will be open for everyone. So already they are in talks with Cisco and Huawei, among others, to implement this in a commercial test network. So that's one interesting architecture. So security again is key part of these architectures. All of these. So there's 3 architectures. There's a named data networking. There's the expressible internet architecture, and there is mobility first. Each of them approach this problem from different angles, and of course, all of them have been testing with verticals. So this Indian project, for example, has been testing with connected cars. Okay, how do you handle deliver information when you have large-scale mobility, as an example of cars going on a highway? Right. There are other verticals in healthcare, in smart grids, and financial systems that other projects are focused on. All of this information is available publicly. You can just search for NSF Future Internet Architectures, and there's a resource page that takes you there. So we also focus a lot on creating open access infrastructure. So, for example, those who were part of the Wi-Fi debates in the past in developments knew that until the loosened WaveLAN came about, Wi-Fi was largely something that nobody could really play with, right? And then after a while, in 2001, we had an open source driver released by the community, which literally made a lot more innovation happen. And many of Cisco's routers, for example, Wi-Fi routers, are based on that software, right? So our goal essentially is to keep that pipeline in the millimeter wave space as well active. So with that, we have a millimeter wave software-defined radio, again, based out of the University of Wisconsin. So again, it's a high bandwidth, programmable phased array antenna where you can, every aspect of the radio is programmable. Again, this is an ongoing development, and they have been working with National Instruments, among other companies, to make this into a much more viable platform that anyone can download and adopt. We already have at least 4 institutions that are using this prototypes. So, of course, no mention of millimeter wave can be done without referring to Ted's group at NYU Wireless. So this is a new end-to-end phased array that we have recently funded. So the goal is to develop a very high rate, enable high rate baseband processing, led by Sandeep Rangan at NYU Wireless. So this again is a combination of equipment from National Instruments and Cybeam, with the goal of enabling large-scale data rate processing with support for low-latency MAC protocols and synchronization and so on. So this is also going to be open source, publicly available, hopefully by, we have been told that mid-May. So this is the time frame that they have given us. Okay, and we have another project at RISE that has looked at practical ways of doing massive MIMO. So again, when we say massive MIMO, we are doing much more than 100 elements, right? So they have currently a prototype that has already can do 144 antenna with real-time beamforming and support mobility, pedestrian scale mobility, and it's deployed on the Rice University campus and is actively supporting users, carrying live traffic right now. So the next generation of Argos radios is going to have, say, much more, 250 plus elements. So one of the other research angles that they are pursuing right now is to take these lessons learned in terms of channel estimation and whatnot and apply it to the millimeter wave domain. So we see a lot of interesting work to come out of this platform. Again, all of these platforms are also open source, available for anyone to adopt, and these have a lot of adoption in campuses in UT Austin, Santa Barbara, and other universities in the country. So again, I noted that NSF is the venture capital for research. So we are looking for game changers, right? And when we say game changers, we are not looking to say, well, we want a new Google all the time. It could also be technologies that lead to existing companies changing their direction or developing new business models. That spectrum sharing can be one example, right? And also the research that we want to fund, we want to see a lot of synergy with other federal initiatives. So, for example, we have a lot of collaborations going on with DARPA as well as NIST on some of the work that we have been doing in the space. And we have all of this work has led to a lot of successes in terms of startups and tech transfers. So this is one measure of metric of success that we see, and we have a whole bunch of them that has been listed here. But where we see us going is a world where we don't have to worry about spectrum as a problem. We all come to the FCC, and I'm sure the FCC appreciates all the attention that they get we all come to them asking for spectrum. But I think, given several speakers have highlighted this, that there is enough spectrum in the world, whether you want to go in the higher bands or not, for us to share. And NSF has been pursuing research that can enable this world. And so think of it as more of a clean slate for spectrum. So what would it take to simplify this whole process of worrying about broadband? Right. Again, remember, we are all this talk. Whenever I talk about broadband, we kind of keep forgetting that there are other users of spectrum also in the world who don't use this for data alone. Right. So we have to be cognizant of it. But we believe that there is still a possibility that we can all coexist happily without fighting over gigahertz and megahertz. Okay. So anyway, and a part of that is the test beds that we are trying to enable. So this is an ongoing initiative. So we are working on it. We'll have some public announcements soon. If you are, as a company, interested in participating and partnering with us, we'll be happy to talk to you about it. This is our vision. This is hopefully to get this out within the next couple of years. A deeply programmable citywide test bed that brings in all these concepts that everybody has been talking about, not just in the wireless world, but also in the wired world, and essentially enable a test city that can be the showcase for all the advanced technologies that we can talk about. And we will make this a reality in the next 3 years. So, thank you.
Thanks, Tiaga. That was very insightful, and thank you to other panelists as well sharing your insights on 5G technology and cybersecurity. So why don't we just jump into a couple of questions that we prepared. So the first one, let's start with the easy one. What are the key similarities or differences between 3G to 4G and 4G to 5G transition from technology, standards, and ecosystem perspective? Why don't we start with you, Amitabh?
Thank you, Michael, for asking the question. So the basic thumb rule of Gs is that it evolves every 10 years, right? So we started with 1G and 80s, and then we are in 3Gs in 2000 and 4G in 2010. 5G will see around 2020, 6G 2030. Now, 3G was the foundation for the mobile broadband, where the HSPA technology was introduced with 14.4 kilobits and uplink was 14.4 megabits, uplink was 384 kilobits. And then it evolved, and generally the key differentiator between 3G and 4G was the spectrum. And 4G, where we see a real broadband with data rates up to 1 gigabit peak data rates, cellage rates of more than 2 megabits and so. But the main difference, both these 3G and 4G technologies address spectrum below 6 gigahertz. And then the spectral efficiency of 4G was 2 to 3 times better than 3G. Now, when we go from 4G to 5G, we know that we are going into new spectrum regimes. So we are looking at larger bandwidths, up to 2 gigahertz bandwidth. We are looking at new spectrum bands. And also, because the capacity of a system depends upon 3 things: the spectral efficiency, the densification, and new spectral bands. From 3G to 4G, we saw improvement in spectral efficiency. In 4G, we saw introduction of small cells. Also in HSPA, we have introduction of a massive proliferation of small cells with interference management schemes. And to improve the spectral efficiency, we have thrown everything in the kitchen sinks in 4G. So when you go to 5G, what new things we have? We have new spectrum, which is at 28, 39, 70 gigahertz. Widths of, as I said, now in LTE we have 20 megahertz carrier aggregate up to 60 megahertz, whereas in 5G we'll have going from 800 megahertz to 2 gigahertz of bandwidth. So we'll use that feature. We'll use massive MIMO feature in 5G, which is absent, which started in LTE, but we'll extend that to 5G with massive beamforming feature. And finally, 5G will not be a standalone technology. It will integrate the existing LTE and also new 5G technology with new air interfaces. So between 4G and 5G, the important part is more spectrum, densification, less emphasis on spectral efficiency. Is that?
Got you. Thank you, Amitabh. Anyone else would like to add on that?
I can add something. If you look at LTE right now, it's a very capable system. And going forward, you'll find that LTE itself is probably going to evolve, as well as air interfaces like NX will enter into lower frequency bands as well. The key thing that we have to understand is that when we came out of WRC 07, it was declared that the mobile industry did not need any new spectrum. And that effectively created this really fragmented landscape of spectrum for LTE, which we used carrier aggregation as a solution to mitigate. So now we have actually, as an industry, ended up investing a lot of our energy into making carrier aggregation work for very wide bandwidth signaling and data transmission. Whereas now we have a situation where the ITU has declared that we need somewhere between 1.3 to 1.9 gigahertz of spectrum just to meet current traffic demands. And then on top of that, if you think about all the new applications and use cases that can be introduced for mobile broadband, we really need to allocate a lot more spectrum. So what I would say is that now we have enough industry momentum right now, and as well as regulatory action to make possible something very, very important. And that is to be able to get large amounts of contiguous bandwidth where innovation can be directed towards providing data transport from point A to point B rather than towards making do with a lot of technological constraints. That, I think, is very crucial.
Thanks, Kumar. Let's move on to the next question.
Thanks, Mike. And it's occurred to me that as new generations of technology have entered the communications infrastructure, security isn't the first thing that we think about. We think about performance, functionality, features, but security is not first, and frequently doesn't come soon enough, and we live to regret it sometimes. So 5G gives us a chance to do it the other way, and that is to think about security very early in the life cycle of a new technology. And maybe 5G includes certain hooks that would allow service providers, device manufacturers, other members of the ecosystem to secure a market advantage by investing in security early. So the question that I have for the panel is, to what extent and why do you believe that this is true? And Paul, I'm going to ask you this question first. Why do you think that's true, if you do, and how can the industry exploit it?
Yeah, Jeff, it's a great question. And I think you have to just look around us to see what's going on in the cybersecurity world and to see how much threat and peril we're under on a kind of constant basis. So I think consumer awareness is much higher now. I think everybody, and certainly in enterprise, is much more aware of the dependence on these technologies for their very livelihood. And obviously they're much more aware now of the threats that face them. So I actually do think that service providers, technology providers that can actually point to very clear advantages from a secure point of view that are demonstrable, I think they do have a tremendous advantage. So I think it does make sense for the industry to invest. I mean, I think the way to get about that, in my opinion, is to recognize that it's no longer a completely vertically integrated system like the previous Gs have been. We've talked about a raft of different use cases this morning, and if you look at it all the way from automotive to industrial internet to healthcare, just providers from different directions with different issues around security. So we have to think about all the new paradigms back to what Matt started with, which is we have a chance to do it right here. If we think about it up front and use this inflection point, secure the control plane because it will be disaggregated in this virtualized world. Secure the management plane because we all know that some of the most prolific threats are to inject the malware or the threat inside of the management plane and use that to propagate that to all of the different things that are connected to the network. Recognize that it's not vertically integrated. We'll have devices that don't come from the same service provider or don't come from the same origin. How do they attest to one another to make sure that they are who they say that they are and they're legitimate participants? I talked earlier about recognizing that not one mechanism for encryption makes sense. It was mentioned earlier that we need to think about decentralized trust models that scale in the billions of internet provided devices. So thinking about those, ruggedizing the RF interface, Amitabh talked about that. I think it's very DDoS attackable today. All the Gs have been. And the privacy thing is a huge thing. The ephemerality of the identifiers that are out there, we have to think about if people are going to trust this network, they have to know that it's not easy for somebody to just simply query the network and find out who they are. So I think the opportunity is rampant here, and I think the threat environment mandates it.
Thanks, Paul. Anybody else want to?
Sure, I'll comment. I completely agree with everything you said. I think security maybe needs to be moved up to the top, ahead of performance and whatnot, because we're not going to have this future connected world that we all envision without the cybersecurity issues being addressed. In fact, 5G needs to be part of the solution, not part of the problem. There's going to be so many more attack surfaces now with all these different devices and different business models. So when I say part of the solution, what I mean is rather than designing a new network and then and not having security, at the forefront, and then waiting for third parties to come along and put solutions. There needs to be the integration of solutions right from the get-go. You can have behavioral analysis where a cybersecurity solution can look into the device or the network and have access to data and visibility that it didn't have in the past, and it can be much more effective. And when you can share, when one device can share what it's experiencing with a database or a connected solution, again, you can make these solutions a lot stronger. So I think it's absolutely paramount. We all talk about more throughput. Of course, that's a part of it. But we really are talking about new business models, new industries. If you're going to have medical devices where the physician and the patient are on the opposite side of a radio link, or you're going to have fleets of vehicles or robotics, man, security is number one.
So one of the issues that I think we all are aware of, that there's a need to introduce security from the get-go, but unfortunately, I think to take the more pessimistic view, evidence has shown that we tend not to, because there are more pressing things that we would like to solve and we are much more comfortable solving. Even in the wired world, if you forget the wireless part, right, it's not a solved problem. And there's a big challenge in terms of what are the attack vectors that you really want to protect against? Because it's not just your network you're trying to secure, it's like social engineering. There are all kinds of attack vectors that can bring down your entire information architecture, right? So there's a need to involve a holistic security view and bring in the right people from these communities as part of the design process from the very get-go. I'm just noting the current state of the affairs. I'm not a ding against any particular organization or other standards groups, but it's just not happening the way it is, the way I'm seeing right now. This is essentially why NSF invested in this future internet architectures, where we wanted this bake-in security from the introduction. But even there, we have seen challenges because there is a mindset among researchers and engineers to kind of not see security as the first priority that they have to solve, because they're just not comfortable at anticipating all possible attack vectors. All you need is one crack in the wall to bring down the whole thing, right? And it's a challenge, as we are seeing increasingly day to day. You just don't know what else can break, right? So, but again, it is important to be aware of it. But I think there's a much more critical need to start involving the experts right now in the discussion process.
Thanks, Tiaga. I think we are kind of past the time that we have. We also want to make sure that our audience will have ample time to visit the demo booth and see the demo as well. So thank you so much for participating in this panel. It's very helpful to get a sense of where things are from the leading technology company's perspective. Thank you.
So what we're going to do now is we're going to break until 2 o'clock. We'll start back up at 2 o'clock. So as he said, there are some tech demos if you go out the hallway here. But what we'd ask is if you want to go grab lunch, you can. If you want to eat in the cafeteria here in the commission, to meet in the back of the room over here, because you have to be escorted up to the cafeteria level. And if you want to go get the demos first, then you can come back here and find an FCC staff. There's food trucks across the street, and if you go out the front doors and go left up to the corner, there's a deli. If you go around the corner to the left, there's a Potbelly's. You can keep your badges, but you have to go back through the metal detector again when you come back in. So if you guys, please, if you want to go down to the courtyard, please come over in the back of the room here, and FCC staff will take you down to the cafeteria. You can leave your bags here. And at the speakers and all, you can leave your bags in the room if you would like. There'll be people in the room throughout. If you eat at the food trucks, you can bring your food back and eat here in the room. Please don't take food into the demo rooms, okay? Okay, so we'll get started here. Just to go over the logistics again for anybody who may have just joined us online or new people coming into the session. We are streaming this live. If you are watching remotely, you can submit questions to the panel by sending an email to livequestions, livequestions, @fcc.gov. If you're sitting here in the room, we have some yellow note cards and some pens in the back, and I'll be walking around. If you get a note card or you have a piece of paper you want to write a question down, just raise your hand. We'll come get it from you. If we have enough time, I know the panels have been very robust and a lot of information's been going out, so if we have enough time, and depending on the volume of questions, we'll get to as many as we possibly can. So the third panel today will discuss creating a regulatory scheme for flexible use in the millimeter wave bands. We have two moderators from the FCC again. The first one is John Schaubel. John is the Deputy Chief of the Broadband Division in the Wireless Telecommunications Bureau here at the FCC. And Bob Nelson. Bob is the Chief Engineer in the International Bureau here at the FCC.
Thank you, Cecilia. And thank you, everyone, for coming to this workshop today. This morning we heard a lot of interesting information about services and technology in the millimeter wave bands. This panel is about how the Commission can create a flexible regulatory framework that will enable a wide variety of services. We have a very distinguished panel here this afternoon to discuss these issues. Harold Feld, who's the Senior Vice President of Public Knowledge. John Hunter, Director of Spectrum Policy for T-Mobile. Jennifer Manor, Vice President of Regulatory Affairs at EchoStar Corporation. Joan Marsh, Vice President Federal Regulatory at AT&T. Davide Jonas, President and CEO of StraightPath. And Michael Dahm, Principal Technology Policy Strategist at Microsoft. And we'll turn things over to Bob. Oh, I should mention, format for this discussion is going to be a little different. We're going to get straight into questions and hope to have an active dialogue on these issues.
Okay, thank you, panelists. First of all, we heard a lot this morning from the technical side on the characteristics and the potential of these particular bands, which in many cases may actually introduce the ability to do some sharing that we weren't able to do in bands at lower frequencies. There are very technical characteristics, and such as the narrow beam widths that could potentially be made from the high gain antennas that we are looking at. In addition, some of the characteristics we're looking at is the coverage areas of the services that would be provided. So those all introduce the potential that maybe some sharing that we haven't had the opportunity to do in lower frequency bands might actually take place in the bands that we're looking at here. So given that as a topic and what we're going from, I'd like to ask the following question of the panelists, and I'm going to direct the first question initially to Jennifer, and I'm hoping that we'll get a considerable amount of discussion once we go from there. The Commission is looking at a variety of sharing scenarios between satellite and terrestrial, between federal and non-federal, and between fixed and mobile. What are the fundamental principles the Commission should follow in working out these sharing scenarios?
And thank you for inviting me. And I wore red so I could be the target and more easily found. But I actually am here. I'm actually excited to be here because I do think there's a solution to what's a very, very hard problem, or maybe not so hard since I think we have a solution. But let me start just to backtrack. With regard to spectrum sharing, satellite operators and our friends in the terrestrial industry both have a very, very long history of successful sharing. And I think looking at that, including coordination that goes on today, is a really good way to think about this in terms of how to build to get to a solution in a way that works for everyone. We're in a different scenario here than we have been in the 28 gigahertz band, where satellite has been able to successfully share for close to 20 years, at least, from if I remember how long we've been doing this, Bob, has been able to share with the fixed service. And here we have existing users, both fixed satellite service and the fixed service, which of course must be able to be protected, and to the extent the terrestrial operators want to continue fixed service, be able to grow. and the FSS, of course, needs to be able to grow. And when new services must have the flexibility that they need to grow as well. So that's the framework that we're really working with. We've been talking with some folks in the satellite industry and also with the terrestrial industry about what would work. And what we've been thinking is, first and foremost, a critical nature of any solution must ensure that existing FSS gateways are protected and are able to grow in terms of adding new antennas to see new satellites where they are, and that they must be afforded protection or what I would call co-primary status. The FSS industry also wants to have protection going forward and not operate on a secondary basis. We have some concerns with the FCC's proposals in terms of auctions of spectrum, both from a policy but also from a legal perspective because of the Orbit Act. And we have some concerns about the practical implications of secondary markets. So we spend a long time listening to some of the terrestrial interests, including my friend AT&T, trying to figure out, is there a way to go forward? And when we think about 5G deployment, one of the most basic areas that the 5G industry seems to be most interested in and why deployments are what I call the urban cores. And from a FSS gateway perspective, that's not an area that we're intending to be in. So we think in an urban core area, we would be able to take a secondary status from an FSS perspective and allow 5G to operate on a primary basis. Outside of the urban cores, where there's an opportunity to coordinate on a good faith basis, that's where we'd like to see co-primary status for both FSS and 5G. So we feel that this sort of environment could serve as a basis, and it's still something that has to be fleshed out a fair amount more, but through coordination, through working together, we'd be able to work with the folks who are deploying as we deploy our Earth stations and our facilities and be able to come up with a way that works well for everyone. We think a similar concept could be used at 38 gigahertz, perhaps with some changes, but we'll stay focused on 28 gigahertz because I think it'll get very complicated if we switch bands too much. So thank you.
Joan?
Thank you, and thank you for inviting us to talk at this really important workshop. So we believe that there are solutions that can be found here. Most of these hard problems can find solutions if you actually sit down with the providers that you're trying to accommodate and have a detailed conversation about what the challenges are and what needs to be accommodated. In that vein, when the NPRN released, we reached out to Tom Stroup and SIA, and I just want to express my appreciation to the association and Tom, because they really were very open to having us come and sit down and having a robust discussion with them about their concerns, about our concerns and our plans and how to best utilize this band. And I would extend my thanks to Jennifer and her team, because we were able, I think, through those conversations to come to what we hope will be a very productive proposal to how to address some of the sharing issues in 28 gigahertz. And I will focus on that as well, but I think the concepts apply in 37 to 39 as well. So as Jennifer said, we heard very clearly that they need protection of their existing gateway stations and the right to expand. We can certainly understand that. But what we are talking about, at least from our perspective, is a fairly easy lift on coordination, particularly compared to some of the things that we've done in other bands. We have extreme coordination requirements in WCS that are way more complicated than this. And as John and I were discussing, we're doing a good bit of complicated coordination in AWS-3. Here we are trying to coordinate with something that's fixed, not moving, important, and Earth stations that number in the tens, not the hundreds. To me, that's something that we can manage. So as Jennifer talked about, at least in the 28 gigahertz, what the specifics, and our teams are still talking to try to work out what this would look like, but coming into the 28 gigahertz, any new mobile licensee would understand that there are certain fixed stations, they would understand the geography of those stations, and that they would understand within a certain perimeter around that station, if they deployed, they would have to deploy subject to interference, potential interference from that station. What we've discovered is you can determine theoretical potential interference, but if you coordinate, very often that interference itself can be mitigated. So we're going to need more conversations to figure out exactly what that perimeter is. I don't think it's going to be big. I think Jennifer's team thinks it might be about 2 football fields. And when you're talking about a license area, let's say we're going to do PEAs, which we've proposed, 2 football fields in the context of a PEA is not a significant coordination lift. It's something that can be accomplished. Now, that's for fixed stations. Of course, the satellite industry wants an opportunity to be able to expand. Again, we're probably talking about tens of additional stations, not hundreds. We don't know where they're going to be. That's more difficult because obviously a licensee coming in can value the profile of a fixed station, but if you don't know where a potential request is going to be in the future, that creates a more difficult valuation risk assessment. As Jennifer indicated, we've talked about this notion of an urban core. So requests for future stations would not be in the urban core or would not be provided the same rights in the urban core. That would assure new mobile licensees coming in would be assured that they would be able to deploy in the urban core, which is going to be of great interest in 5G for new mobile licensees. Outside the urban core, of course, it would be a matter of coordination. And I'm just going to assume in any 5G build there are going to be parts of almost every license area that could easily accommodate a new fixed station without much interference to or hindrance of either current 5G deployments or future 5G deployments. Again, we're not talking about a big area of a license. So that's the general concept that we are working with. And again, we're seeking to accommodate fixed stations, create a potential for future deployments while giving the new mobile licensee maximum flexibility in the license area, subject to working with satellite providers to ensure their needs can be met as well.
So a couple of things about this that I think are very important. So first of all, I really like the idea of interested parties and stakeholders working together on this. I think that one of the more important principles generally as we've been moving to, and particularly in an area like this where the technology is still in its infancy, is to push for all of the users to work it out and share with each other and find ways and mechanisms to do that. So, in that vein, actually taking a look at the problem and not saying, well, someday I might have unlimited ATC rights, so therefore I want to have no, activity terrestrially, or, someday we might want those 2 football fields worth of, all of these things are, to my view, very positive and obviously things that the Commission needs to be looking at. And there's a but coming. The problem with this, and again, particularly when you have a technology that's at its infancy, is it envisions a world of users and stakeholder interests that will be very similar to what we have today. This is one of the biggest problems whenever we're looking at a new technology, is that the first thing people do is assume it's going to be like the present, but pumped up more on steroids, and we'll do more with it than we were doing before. There are a lot of different uses and use cases, as people have talked about. It may work well, in some bands, to say, well, one of the goals of licensing, sort of to answer the broader question, is, well, let's experiment. I think it was about 10 years ago that Yochai Benkler proposed the experiment of, well, let's take 500 gigahertz and 500 megahertz and make it unlicensed, and 500 megahertz and make it licensed, of roughly equivalent spectrum, and we'll just run the experiment and see how that works out. There's value in that. One of the principles I think that the FCC ought to be keeping in mind is diversity, but there's also flexibility and looking out for the stakeholders who are not on the scene. And that's where the piece to me that's missing in this discussion is, the use case may change. Methods of technology may change. We all think we know how this is going to work now, and we can imagine how we plug it into future devices. But it's not clear that we're even going to want to do wide area licenses. We might have other means by which we want to, assure exclusivity. And so I think in terms of looking at principles, one of the principles obviously should be listen to the stakeholders and encourage the stakeholders to work out these problems. The other one, though, is it's still got to be the FCC that makes the decisions here, because you got stakeholders that ain't even been born yet. I can assure you that today's stakeholders in wireless would never have done AM radio. But, you know, a lot of people like it. So we're actually revitalizing it in a bunch of different ways. But, you know, again, how we do these things, we're going to, you know, just in a few weeks, we're going to start an auction about reallocating the TV band. You know, again, we would have done a specific band in this way now because the technologies and the needs change. So one of the things that is a very important principle in all of this is, you know, how is the FCC going to provide enough certainty to manufacturers so they can build, while at the same time also retaining sufficient flexibility that as the technology grows and develops, we can expand to include these new developments. I'll wrap this up by just suggesting a couple of things that I think are important. One is the FCC may want to designate some bands that are currently on the table for future rulemaking. That is to say, you know, we have a number of bands that have been designated. I know there was grumbling by the Republican commissioners that the FCC didn't designate enough bands. For some of these bands, it may be sufficient to say, okay, you know what, let's do rules for the 28 gigahertz band, for the 39 gigahertz band, where people have some ideas. Let's designate that we're going to do something in 37 where it'll be some kind of licensing exclusivity, not necessarily area licenses, not necessarily something else, maybe site licensing, maybe something we haven't even considered yet, but hold off on that to see how the experiments in the other bands work out. And again, while I'm a huge fan of unlicensed, and think that, you know, we filed comments saying, you know, it's a great thing that the Commission wants to expand the level of unlicensed use. I think, in fairness, we ought to also be thinking in a similar way. We've proposed hybrid models like 3.5, which we think are useful because that would let you actually get the exclusivity in the football field-sized space without needing to worry about more coordination mechanisms. But again, on a number of these where we're trying to go for shared, I think we need to be designating perhaps some of these bands for, this will definitely be for shared general access. These for very traditional unlicensed type. We'll think about, we'll watch how that plays out here. The final thing I will just add is I really think licensing by rule for indoors is a dumb idea. And there's a question of, and in this case it does expand to a general principle, don't give rights for rights' sake. The rationale that we heard a lot in the 90s that, well, property rights, and clarification of property rights will solve everything, has not played out even in the bands below 5 gigahertz. It's just not that simple, and this isn't actual real property. So for the same reason, I'm thinking, like, if it's going to be indoors, just do it unlicensed, and that seems to be a very good, flexible model, and there does not seem to be any significant value add of having licensed by rule. Congratulations, along with your condo comes, an exclusive right to this amount of spectrum within this space. There's not going to be, or I don't think there's going to be an Airbnb to let people lease out the spectrum in their condos.
Well, I just wanted to add with that. Thank you for having me. The premise of your question is, the type of sharing that would be facilitated to help move the process further along. I would just add, on top of what others have already mentioned, that any process should not be overly burdensome. And I think when you look at the type of sharing that we're talking about, particularly with FSS operations, as was mentioned, we're doing it in AWS-3. We're doing it in the 1695 to 1710 band with NOAA. And so we have a lot of past precedents where we we've shown that we can do is we can come up with a framework on how to pull this off. So it was mentioned in the NPRM, the possibility of importing, the 3.5 SAS solution. And I think we need to take a step back and really think about what the SAS was intended for. The SAS was really intended for radar operations to sense with the environmental censoring network. So the FSS operations in 3.5, again, those are known locations, and those will just be added to the database. So there's really no need for a SAS in millimeter wave bands to offer up the type of protection that we're going to try to afford for the incumbents.
Thank you for holding this forum, and I would say that depending on how you look at sharing, if as part of the sharing of the bands it's user share, then you would need something like a SAS to do it. So I think if you fundamentally don't think there's a need for user share as a mechanism for ensuring that the spectrum is highly utilized, then that's true. I mean, but if you believe that there's merit to having some sort of user share regime just to make sure spectrum doesn't lie fallow, or to be a persistent incentive for licensees to build out, then there's really some need for a SAS, and a database is okay for a certain level of complexity, but in order to do something like user share, you will need something with a little more capability, which is what a SAS has.
Thank you guys very much for having me on the panel and for letting me sit with the esteemed panelists. In terms of sort of the unknown, as we've been talking about, of what the different use cases will be for 5G in 28 gigahertz, 39 gigahertz, and all the other frequencies that are being considered now and in the future, that's part of the issue in terms of an incumbent license holder or a prospective license holder to say that, well, we'll just push it out of the urban core and therefore it won't be a problem. Well, that presumes that we already know what the use cases are going to be for 5G. What about when the use cases might actually push out of the urban core and start pushing into the same network areas where satellite is operational? The other thing is I do think that the NPRM actually tried to already straddle this tension by allowing satellite users at 28 the opportunity to gain sort of an equal footing by participating at the auction process. And so I think that's one way in which that can be accomplished, to allow satellite users to have the same level of access as terrestrial users. Aside from that, there are methods, secondary market methods, where if in fact satellite does value a certain area for their usage, there can be disaggregation, there can be deals struck between license holders, incumbent license holders, and the satellite industry. So it doesn't need to be something that I think is set out from day one from a regulatory perspective. I think there's the opportunity to allow the industry to regulate itself and to allow the satellite industry and terrestrial services to come together and figure out what in fact is the best way to work.
I think what I'll do is since we kind of had a myriad of topics that kind of went through there, I think what I'll do is I'll open it up for rebuttal a little bit on this one here. Give everybody a little short period of time before we go on to the next question. There was a couple of topics, for instance, market-based mechanisms and stuff like that were brought up. So if anybody wants to say anything further, beyond what they just said, go ahead.
A couple reactions. I'm going to say to Harold, I agree with a lot of the things you said, Harold. And we don't think that the proposal that we're looking at in any way would undermine flexibility and the ability to innovate and bring new technologies. What the proposal attempts to do is acknowledge for the new licensee coming in that there's part of the license area in which they may have to coordinate and deal with the potential for interference. And by the way, it's not a big part of the license area. For fixed stations, it's a relatively small part of the license area. And again, consider the Washington DCP. If you're the license area in the Washington DCP, and there's a gateway station up in Gaithersburg, So you're on notice that for some small part of Gaithersburg, there's going to be a coordination requirement and the potential for interference. But again, we're talking probably something about like 2 football fields or less. So, I feel like everywhere else in the P, then the licensee has full flexibility, and innovation and technology has a very fertile ground to emerge. There certainly are other solutions we can look at, like Davidi said, they could come in and potentially buy their own license. But depending on where the argument about license size lands, do you want a licensee buying, for example, an entire P for the deployment of a single earth station? It doesn't seem like it's a very effective use of the other areas in the license. So there's gives and takes. Our solution obviously is not perfect, but we don't want perfection to be the enemy of a good, solid solution that unlocks the most value, that protects incumbents and their investment, and that unlocks the most value for future licensees.
Well, okay, once again I'm going to say I agree with a lot of what Joan is saying. I want to, though, just stress part of my concern here is we're starting with a bunch of assumptions, which goes to the last point I made and which was raised in this question of opportunistic sharing of why do we give the rights? What are we trying to do? What are we trying to accomplish? Is it because we believe that there are particular reasons and use cases why you must have exclusivity? Is it because it's an economic incentive question? Is it because this is how we've always done things, and now we're just talking about, how to take a system that we all are comfortable with as it is backwards compatible with the existing use cases and plug that in? Let me just suggest a couple of things that are potentially compatible with the kind of solution we're talking about, and which I think become more important when we're talking about allocating significant geographic areas where a P is small for a license area at lower band spectrum, but given the propagation characteristics and constraints of the spectrum at this level, that is potentially a very large area for what is likely to be a small cell type deployment. We can have different forms of opportunistic sharing. We've talked about user share, which if we're going to have broad areas of exclusivity, then having means by which others can potentially use the spectrum without using a SAS or using something else in a non-interfering manner while the use case is building, while deployment, is happening at its steady pace, is potentially a very significant addition to the ability to use the spectrum efficiently and with a variety of use cases. We should take a look at things like sensing. I mean, sensing has been slowly getting more mature. We're looking at it in 3.5 as a means of getting rid of the federal exclusion zones. Should we be saying, sure, let's do significantly sized area licenses on an exclusive basis, but allow unlicensed opportunistic sharing given sufficient sensing qualities, so that if you can use the spectrum in a way that's non-interfering with the primary user, we do that. Should we look instead at some sort of hybrid system where for competition purposes we say, yeah, we'll have a primary user for a geographic licensing area, but you have to lease out a bunch of space to other potential users because we want to make sure that there's adequate competition within a service area. These are all important questions that are enabled by the change in the physical characteristics of the spectrum. We have an enormous diversity of licensing models in the existing spectrum uses right now, going up to 6 gigahertz. And all of those Some of them have been successful, some of them aren't, some of them were successful when they were deployed and changed over time, but we had a lot of different experimentation going on. My concern is all of these differentiations we've made here between low band spectrum, middle band spectrum, high band spectrum, from up where we're going to be, it all looks the same down there. But we have more diversity in all of these licensing models or have tried than what we're thinking about now up here, despite the fact that this is a new world and with a lot of different space to play with.
We could go on. Somewhat related question. In the NPRM, the Commission expressed for a balanced approach to authorizing service in these bands that incorporated licensed, unlicensed, and innovative sharing approaches. As a conceptual matter, panelists, do you agree with the concept of incorporating a variety of licensing mechanisms?
I think I just answered that.
Yeah, but John, if you want to.
Well, I think the hybrid approach is something to be cautious, very cautious about that. And I say that because, you can envision a scenario where you have a license area and you're going to have the notion that you're going to have an overlay of other uses that potentially could be co-channel to your license area. Understanding RF knows no boundaries. So how are you going to manage the interference scenario that will ensue should we go down the path of this hybrid model? So I think in concept, yes, I think a portion of the spectrum for unlicensed, a portion for licensed for sure. But when you mix and match without a good regime as to how you're going to manage interference is going to create problems in the band.
If the unlicensed or the shared is secondary to the license, would that still cause problems to the licensed? I mean,
if you're going to overlay without a good mix, and again, you got to understand how the rules are going to be established for this hybrid approach. But if you're going to allow unlicensed devices in this hybrid model to operate at will, where you have no idea where they're going to be in a licensee's area, you will have interference. And so I don't know how the structure is going to be played out unless you had some sort of mechanism short of sensing. But aside from that, you're going to have interference.
Right, but so it may not be purely unlicensed, but in the 3.5 gigahertz band, sort of lightly licensed or licensed by rule, which sort of addresses that. And so it may, in certain bands where it's shared, it may not be possible to have pure unlicensed, but it would be possible to have unlicensed like.
Well, the 3.5 is a very different scenario than what's been purported in the hybrid solution for 37 gigahertz. In 3.5, you've got a portion of the spectrum that's set aside for GAA use, a portion of the spectrum that's set aside for PAL use. So you're not going to have interference in those cases. Now, you've got the censoring network where if the PAL is not using the spectrum, the SAS will allow an unlicensed entity to come in and use that spectrum. Sure, that's a managed process. But when you're talking about trying to implement a system like 3.5 in millimeter wave bands, where the sensing is going to be probably much more difficult to do at those frequencies than it is at 3.5, I'm just not sure how you're going to do there if it's even technically viable at this time.
And I think we would agree with what John just stated on this. You look at a band like 37 to 39, there's a lot of territory there. There's a lot of real estate. And we think that there is opportunity for all types of licenses there. So, our proposal is look at that band as one contiguous band, build some very broad bands there, and I think the record supports 200 megahertz minimum, maybe larger. And then if we want to accommodate different licenses, it's kind of like in 3.5, different parts of the band could be permissible for unlicensed, where licenses would be accorded in different other parts of the band. And I certainly agree the hybrid licensing scheme with the indoor building proposal, I'm going to agree with Harold that we think that that's not a really good idea at all. If that type of experimentation is desired, perhaps you could pick out a single proposed block in a band and try it there. Not that we're supporting that particular proposal, but if there is a desire to experiment when you have a band the size of 37 to 39, you can pick out one small part of it and perhaps pursue an experiment there.
Let me ask a follow-up question on that. The Commission's proposal for 37 was designed to facilitate a third type of network deployment, privately deployed networks that could provide 5G communications for advanced enterprise and industrial applications not suited to unlicensed spectrum or public network services. Do you believe there is demand for and interest in such type of deployment?
Actually, I don't. I think in that, I go back to what Commissioner O'Reilly said in his opening remarks about, be careful with the experiments. I think there's a lot of talk about 3.5, about taking a lot of the concepts there and importing them in millimeter wave, and yet 3.5 has yet to come to fruition. We're still working through that. So we don't know how that process is going to play out. So the idea that we would be setting something up, I think if you had it as an unlicensed, and you had a portion of that spectrum that would be set aside for unlicensed, whether it's the contiguous 3 gigahertz from 37 to 40, a portion of that, I don't know if you want to make it unlicensed, but maybe a portion higher, than 64 to 71. I think if you're going to try some of these experiments for a different type of network deployment, it would just seem to me you'd want to pick a part of the band that's higher in the spectrum that would lower the risk for some 5G deployments that we're definitely going to see at 39 or 38 and 29.
So I was not here, unfortunately, for Commissioner O'Reilly's earlier remarks, but as you may have gathered, I take a somewhat opposite perspective, to phrase it. Beware of falling into beware of falling into stale thinking. Beware of falling into the trap of the familiar, which is equally a concern, especially when here, let's face it, we're at the beginning of the deployment and process. We're thinking about this stuff. Everything we're about to do here is an experiment. Whether it is an experiment to see if the old licensing regime transfers up to millimeter wavelength, or whether it is a different kind of experiment, it will be an experiment. So we shouldn't delude ourselves that somehow by hewing to traditional licensing regimes and following, a scheme that was developed over 100 years ago because radios were too dumb at that point to be able to exclude unwanted signal, that's not an experiment, because that is an experiment into whether that's going to transfer. And I would say, based on some of the experiments we've already done, like LMDS, that kind of exclusion doesn't seem to be, particularly useful. I would say that with regard to the proposed kind of service that you're talking about, it strikes me as awfully similar to the old Part 90 rules with spectrum coordination committees to try to allow private licensees to take their licenses and use them in sort of customized ways that worked until you had too many licensees to have that happen, and then it became too crowded for the spectrum coordination committees to manage properly. I think that given the propagation characteristics, the kinds of things that you're talking about could be satisfied by an indoor unlicensed only. Now, there are, in fact, I think, pretty easy ways to make sure that it stays indoors, again, kind of based on the propagation characteristics of the spectrum. Whatever you're going to ping into a wall, it's going to ping back. But the question then becomes sort of a broader, well, what about corporate campuses and other things that are not purely indoor or outdoor? That's an interesting question. The current hybrid proposal, by focusing on an indoor only, doesn't do that kind of experiment. Arguably, something modeled on 3.5 does, but again, I don't want to, fall into the trap I just identified by, pushing the thing that I know. it's a problem to think about, and maybe resolvable through much greater flexibility in the secondary licensing rules, or alternatively in permitting some kind of secondary use for beam formation for outdoor on a larger corporate campus. There are a couple of good ways to be thinking about this, but what the commission has put on the table so far doesn't cut it.
I just want to hear everyone talking, and I appreciate what everyone's saying, but I want to remind this is an incredibly important expansion band for satellite. We're actually, and so no matter what satellite has to be part of this band, we're proposing that you set around a specific block of spectrum with similar rules to 28 gigahertz, though here we do have a slightly bigger protection zone, because in this band we would be interfered with, and it would take approximately 2 kilometers. So maybe one of the approaches we're putting forward is that you set aside a block of spectrum. We've proposed 1 gigahertz, but other folks may believe it's more. I don't want to say what the right number is. And folks can share that band with us under the rules under 28 gigahertz, and perhaps they pay a less expensive a discounted auction price. And this really goes to the market mechanism question that was raised earlier that you didn't let me respond to. But I will now, which is the problem is that satellites often, they take a long time. I'm looking at my friends from Lockheed Martin. They take, 3 to 5 years to construct a satellite. So if auctions happen tomorrow, we don't even know where our gateways are going to be today, if you asked us. So to participate in auctions, besides the fact that I think they're illegal and they're bad policy, there's a real practical implication, which is I couldn't tell you where my gateways are going to be. And then, of course, under the FCC's rules for secondary markets, there's no incentive for anyone to negotiate with us, and we are seen as a competitor to some folks. So, but I do think 39 gigahertz, besides for some of the ideas thrown out here, has to be available to the satellite industry in some form.
As a primary holder in 39 gigahertz, I think it's much more complicated at 39 than it is at 28, given that it's downlink usage. And again, there has to be the realization that the use cases for 5G are going to be vast in number, and we believe that the coverage area is going to be significant. So the downlink possibility of satellite interference could in fact cause significant interference to the primary user, the incumbent user, the terrestrial users. The proposal that EchoStar put forth in terms of carving out a section of 37 to 40, first of all, it already presumes that the band is now 37 to 40, which I don't think the Commission has yet decided on. But assuming that was to happen and it was 37 to 40 and now 39 to 40 is sort of primary for satellite and 37 to 39 becomes a playground for terrestrial. I think that's something that's, we appreciate that an innovative solution that's being brought forward. Obviously, it's something that would have to be carefully settled with the incumbents and with the FCC, and how do we deal with the licenses that currently exist in 39 to 40, and how are we made whole within 37 to 39. One of the hesitations that we have, and I think the Commissioner is very clear about this, is this is an immediate and necessary rulemaking for the benefit of U.S. and for the benefit of the U.S. being the leaders in 5G. And to the degree that we start creating complexities, I agree that we shouldn't be afraid of the unknown, but I do think that we should recognize that the unknown, or using some type of model that's untested, is going to take time, and it's going to have to be maneuvered in a way that I think will take away from that expeditious deployment of next generation solutions in the U.S. and potentially take away our leadership position. I think that's something that the Commission has to be very careful with.
Just to get back to your original question about the hybrid model. And the original PCAST proposal had the 3 tiers of access, protected incumbents, then the priority access tier, which was those entities that needed a little more protection, and then you had the general authorized access. The Commission made a decision to have open eligibility for the priority access tier. So in the context of the original PCAS model, the formulation of having the priority access layer for entities that need a little bit more licensing or license protection, that made sense. I agree with T-Mobile and AT&T and Harold that, for this particular band, that doesn't make sense.
I think what you're hearing is certainty. I mean, that's the underlying, word that comes to mind when I think about this discussion, is because you're talking about trying to be innovative. So you've got to balance innovation with not putting rules in place that overcomplicate the process. I think as we all prepare to roll out 5G networks, we're going to need that certainty. So I think it's very important to find a mix. I mean, if we're going to talk about freeing up some of the spectrum for unlicensed, that's fine. But it should be done in a manner that's consistent pretty much with what we have now, and recognizing the fact, if you're talking about a hybrid model in millimeter wave, the physics of the band are so high, I don't know how you would sense and have a database or a sensory network that would be able to give you that type of flexibility that you have in 3.5. It's just a very different band.
Well, I just want to add, there's certainty, there's flexibility, there is innovation, and sometimes these are at cross purposes with each other. And again, to go back to a point I made at the beginning, I'm not saying we shouldn't be willing to take, a chunk of space and say, okay, let's do something that is much more traditional, exclusive, in a way that the current providers are going to feel, comfortable enough to deploy in. I just suggest that, number one, in answer to the question of, are we feeling in a rush? Is this a high priority? I recognize there are international pressures. I also recognize that taking a little extra time to do it right, rather than having to try to do it again, is not going to kill us. We were first in 700 megahertz, go us. In some ways, that was very good, but I also know that everyone I've ever spoken to has said, thank you, U.S., for screwing that up so thoroughly that we all know never to replicate that band plan ever again. So, there's a balance, and we need to be thinking as we move forward how to provide the certainty, but also how to provide the flexibility and, frankly, if necessary, the corrective mechanisms.
Thank you. Moving on to another subject, which Joan has already touched on a little bit. What is the optimum channel size for the millimeter wave bands? Joan,
so I'll take
your answer. At least 200 megahertz was your
well,
answer.
that's what we said, and I really feel like you have to look at each band separately. So we said minimum 200 megahertz, but 28 is a very different animal than 37 through 39. Obviously, with everybody, I think there's complete agreement in the record that this is a waste of exercise unless we get to very broad bands and very wide channel size. It might make sense to look at 228 gigahertz because there's less real estate there. It might make sense to look at 400 or larger in 37 to 39 because there's a lot more space there. And even within a band, you might want to have a variety, again, to create a diversity of licensees. So maybe within a band, you might want to experiment with a couple 200 megahertz bands and maybe a couple 400 megahertz bands, et cetera. So I don't know that there is an optimal, but I think that each band should be looked at separately as we proceed through this to try to create a diversity of opportunity within the band.
I'll just say I agree with Joan. I mean, particularly in the point on diversity of licensees, because, depending on how the spectrum is licensed, there's potential for maybe, one carrier to have a lion's share of the spectrum or a lion's share of key markets. And if you're looking at an ecosystem for device manufacturers and chip manufacturers, you need to have enough diversity to make the ecosystem go. And also for companies out on the edge that use the services, you really want, or Microsoft would want to have multiple wireless providers to provide that service rather than sort of being at the, subject to one or two in the event that, we want our customers to be able to access services over 5G networks.
Yeah, to put it another way, I would say that, the channel bandwidth should be proportionate to the amount of spectrum being offered in a given band. That's the way I think you'd want to look at that. And I agree with Joan and the folks at Microsoft that, it's, if you look at 64 to 71 gigahertz, I mean, that has the potential to offer up, 500 megahertz channels. And so you have a lot of spectrum to play with. Whereas in these other bands, I think you're going to have to be a bit more judicious on how you set that, and also to put a band plan in place that is competitive.
I do think that one of the things that we should be mindful of is, even now in the lower bands, we're looking at a lot of channel aggregation type technologies. And how are we going to do this? So what is the optimum size for a channel is very difficult to predict. I agree with everybody about that. This may go, though, to one of the questions of thinking about, okay, are we seeing technologies that would give us comfort with regard to particular mechanisms? Can we say, okay, do we think maybe smaller might be better to allow a greater diversity of new entrants, because if we're doing this through quotient efficiency type stuff, there may be channel bonding technologies that will allow us to effectively create larger capacity going forward, if that's the answer? Or alternatively, thinking about it another way, will there be opportunities to break up and lease out channel capacity if we, auction off or provide or make available through unlicensed, and again, this is actually one of the advantages of unlicensed. It can be a huge channel size. I don't have to use all of it. But again, it may be if we have big channel sizes, we might then want to leave open mechanisms by which you can sublease or otherwise subdivide the channel to provide that flexibility.
Davide actually touched on this, and this is actually leading into the next question. For the 39 gigahertz band, several commenters have proposed changing the band plan from the current band plan, which is paired 50 by 50 megahertz, to a band plan providing for wider contiguous channels. What is the best way of transitioning existing licenses while ensuring that the existing services are not disrupted?
Our proposal was to allow that to be an elective process, so that the incumbent license holders have the opportunity to determine if they in fact do want to engage in some sort of a swapping opportunity. We're fairly committed to it. I think we're probably the premier. I don't want to say architects, but we're the premier company pushing for that type of an opportunity. We think it creates greater value for the commission, and we think it creates greater value for the band as a whole to be able to have these larger contiguous blocks. But if the commission wanted to take a more top-down approach, certainly it could just be that this is the way the band is going to exist, and people are going to be moved to here, here, and here, and you'll have to just suffer the consequences. And whatever the costs associated with that are, will have to be borne. I would say I can't speak for other license holders, but we would applaud the commission if that were the result, because we think that is an optimal use of the band, and we'd be willing to take on that economic burden because we do think that would create the greatest public benefit. At the same time, though, we're not sure that the commission wants to take that direct an approach, and so what we've proposed is to allow it to be elective, and given that there are not that many license holders, we think that on the whole, with Straight Path and the commission working together, we think that can be accomplished in a multiplicity of markets.
I would say we support that as well. We think it gives an opportunity to rationalize your portfolio of licenses if you can do a swap in advance of an auction to essentially make sure that you're kept whole, but at the same time align it to in a manner that not only brings value to the spectrum that you already have, but you can also work it to minimize disruption. So I think if you do that in advance, it's going to make the auction that much more successful, because now you're going to have aligned blocks. You're going to have the legacy issue to deal with.
I just throw in two cautionary notes from personal experience over the years. One of this is the incredibly painful transformation of the ITFS/MMDS bands into the BRS, EBRS bands, which I, as a young lawyer in private practice, was something that I started on in the 90s, and it was already going on for several years, and it was already painful, and it's still going on, and it's still painful. There are hazards, because one of the mechanisms that was tried there were things like overlay and efforts trying to negotiate. The other issue that I would remind people of is how we ended up using the second 700 megahertz auction to try to correct some of the problems that emerged from earlier auctions like the guard band auction. In all of these cases, the lesson that I would take away is you need to have some kind of motivational backup to deal with the holdout cases, and an ability, as we ultimately did in the 700 megahertz auction, where there was one holdout station and the commission just said, fine, you know what, we're exercising our 316 authority. You're over here now. I think these are generally good idea. Market mechanisms certainly provide the greatest opportunity to reach the most efficient solution, but they need to be structured in such a way that there is actual pressure on both sides to come to a deal. That one side doesn't just dictate to the other side, and that there is some mechanism for resolving in a speedy fashion the inevitable holdout problem.
We're in favor of that.
And I think we agree, and I really appreciate Stray Path coming forward with this proposal. I think there's wide agreement in the record that we need to rationalize this band away from the paired arrangement that it has right now, and it seems to me that there are mechanisms, including, I would say, more incentives. We should create more incentives as opposed to hammers to have current licensees be able to keep what they're using in a way that's rationalized to the future structure that we're heading for. And again, I think if the Commission sits down with the incumbents, I suspect that there are solutions that can be made available. I don't think this is as complicated as BRS, but I certainly appreciate the caution that the pain could be there.
Final question. In bands where the Commission chooses to institute geographic area licensing, the Act requires the Commission to establish performance requirements to ensure prompt delivery of service to rural areas, to prevent stockpiling and warehousing by licensees and permittees, and to promote rapid investment and rapid deployment of new technologies and services. What is the best way for the Commission to comply with that statutory requirement in the millimeter wave bands?
I could jump in to be first on this. I think that what's come out during the comment and reply comment periods is that there are multiple potential ways to measure usage. Some could be population based as it currently stands. Some could be usage based or bits based. So I think I could say for Straight Path, our approach at this point is that the Commission should sort of take an all of the above approach, because until we know how 5G is going to get deployed in these bands, I think it's a little bit presumptuous to determine precisely today how it's going to be. At the same time, we don't think that it's unreasonable for the Commission to say, okay, well, given that we have all of these different suggestions, we have to choose something, and we can't just leave it completely nebulous. So we're going to say it has to be some realistic population coverage. We think that that's something that's reasonable. You have to, in the end, as somebody said earlier, we don't want perfect to be the enemy of good. So we do think that ultimately the best way to measure those performance metrics will end up being through multiple different types of metrics. But in the initial going, it might be more logical for the Commission to just choose a particular way of measuring it. And given that the traditional model has been to do it through population coverage, I think that might be a reasonable approach.
So I'll try to keep it quick points. One is this is a great plug for opportunistic sharing. Opportunistic sharing ensures that there is deployment and efficient use of the spectrum. It also, I would have urged for some time that opportunistic sharing, either through real-time spectrum leasing or through just use it or share it, ought to be seen as a fulfillment of your build-out obligation if you're permitting opportunistic sharing in some way that's significant. So, this is one case where I'll say, well, let the market sort it out. If the best way that the licensee thinks of sharing and making sure that these obligations are being met is to let other people meet those obligations for it, then good. One man's dross is another man's treasure. But the other thing I would suggest is, because of the unique propagation characteristics, where we know we're looking at a lot more small cell deployment, is that there is really an opportunity here to not just go by broad categories of, this much substantial service to this much of the general population metric, but to actually target deployment in specific areas. One could even imagine going on a Google Street View level and saying, all right, you know what, we expect you to be able to deploy in this rural area over here where that makes sense. And we can target along Main Street over here. Come on, guys, deploy. And we could we have a capacity not to rely on, proxies like we've relied on in the past, but to actually get very granular and specific to make sure that the build-out obligations meet the requirements to serve the rural populations.
We've really struggled with this question. What should a performance requirement look like for 5G? We know it's probably going to be small cell driven. We know it's probably going to be very localized networks. And so to some extent, the traditional population covered or geography covered doesn't make a whole lot of sense to us. And I think we'd be reluctant to have the Commission go in that direction, given that we really don't know what these use cases look like. I've been thinking along the lines of what Harold just outlined, and we're agreeing a lot today, Harold.
We could talk privacy and change that.
Yes, we would change that. But we know that the deployment in a dense urban core is probably going to look very different than deployment in rural. Not that there's not going to be a 5G play in rural, but it's probably going to look different. So I think we need to be more nuanced in where we go here, and maybe initially we just need to understand more, move forward with a framework while putting a placeholder in here so licensees understand performance requirements are coming, but do more due diligence on what these deployments might look like and how we can take a more nuanced approach to ensuring that the spectrum's used. We certainly support performance requirements to ensure effective spectrum use.
I just add 2 cents onto what Joan said. I think just one other thing in terms of flexibility. I think it should be, we should remember that the at least in 28 and 39 in particular, where that's we're focusing our attention. There is the flexibility to also use it for fixed usage, and so fixed usage might be a population metric may be a much more appropriate type of metric to use. So, we do have to recognize that we don't think that 5G or the upper millimeter wave flexible bands are necessarily only going to be small cells. In fact, we don't believe that. We think that they're going to cover wide areas as well as small cells and have multiple different use cases. That's why, we're sort of saying, we're waffling a little bit at this point because we are not committed to a particular use case yet. But if I had to choose from among all the ones that that I don't know of, I'd choose the one that I do know of, which is population coverage.
So performance is going to be really hard for a number of reasons that a number of the panelists have outlined. I think even looking at Internet of Things, how do you evaluate that? So I agree with Harold. I mean, as a mechanism, use it or share it from the beginning could be viewed as in lieu of performance measures, because I look at the investment, the mobile operators are going to have to make in the next couple of years. There's an incentive auction coming up. Then they have to build out on the spectrum in the incentive auction. There'll be an auction for 3.5 gigahertz spectrum. Then they have to build out on that to meet those requirements. And now, there's going to be auctioning or some sort for licenses in 28, 37, and 39, and there's the expectation that they're going to also have to concurrently build out on all these things. And if the Mobile Now bill that was reported out of the Senate Commerce Committee becomes law, there'll be more spectrum in the low bands available for auction. So that's a mind-boggling amount of investment. And, and I know, despite the best of intentions, it just may be slower than it is. So you want to have that flexibility. And so rather than having some firm performance requirements that, at some point, the commission may have to just put some safe harbor, if you start off from the position of have it user share at the beginning, in lieu of the performance requirements from the start, that may be a way of allowing the band to mature at at its own pace and allow more rational investment to grow the band, as opposed to having to dump money in just haphazardly just to meet whatever the performance requirement is.
But how do you measure use it? I think that's the problem I would have with that is, like, if we're struggling to measure performance requirements in millimeter wave, given the physics of the band, how would we measure the usage requirements and make the determination from that we could now share?
So to use the example from the 3.5 gigahertz band, the SAS has all this information from all the base stations and from the general authorized access, and it also has some information from the carriers. And so if you know where all the base stations are, then you would be able to, I think in the 3.5, each base station has to have some sensing capability to report on its local environment on available channels. The SAS, or the multiple commercial SASs, would be able to paint a picture of where the spectrum is being used and where it's not used. So the mechanism that I'm thinking of is where there would be places where the licensed carrier has not rolled out service, and that could be say it's a county. If it's not an urban county, it's a less densely populated county. It could be used for backhaul or point-to-point communications. And in some urban areas, you may pick and choose which markets to roll out and the time frame. So it's the use of the share. It would be secondary to the license service. And it has to go. And once it's licensed, then it can't operate there.
Well, again, we're going down a path, I think, on 3.5 that, again, is unproven. It's still in development. I think the commercial realization as to how that band plays out has yet to be determined. So particularly in these bands, I guess my concern would be going down that path would be a discouragement to investment in some of these bands where we need the spectrum for 5G. So
because everything else about 5G is so proven and so certain.
Well,
at the risk of ending a very interesting and lively conversation, I realize we've gone a little over our time. I'd like to thank each of our panelists very much for engaging in informing discussion.
Thank you.
Thank you.
If everyone could please take their seats, we're going to get started with the next and last session, please. So the last session is going to be more of a fireside chat type of panel. I know we're running a few minutes late. If time allows, we will try to get to questions. So remember, if you're watching remotely, you can submit an email with your question to livequestions@fcc.gov. If you're sitting here, there are note cards and pens in the back there. Just raise your hand and we'll bring you a note card and collect your questions from you. So we'd like to get this started off. We have two FCC senior staff members here with us. We have Julie Knapp, who is the Chief of the Office of Engineering and Technology, and John Wilkins, who is the Chief of the Wireless Telecommunications Bureau.
Thanks, Cecilia. So the good news is this is the last panel. And they set the bar high with the last one because it was pretty lively. So it is my great pleasure to be joined here by John and Paige Atkins, who is with NTIA, Fred Moorfield from DOD, Nadagomi from NIST, and who did I leave out? And Renee Gregg, how could I leave you out? From OSTP. We were going to have a fireside chat, but the safety officer nixed the fire in the meeting room. So I should tell you up front, we talk all the time. There's a lot of coordination that goes on across the government just day to day. And we really need to do that to make sure that the spectrum, which often does just not fall into neat buckets of the federal and non-federal, because so much of it is shared that we have to work closely together on most issues. And I was glad to hear as we went through the day so many folks talking about, well, it's not just millimeter wave, but it's also high band, low band, and mid band spectrum. And because so many of the things that we do cut across not just millimeter wave, but other parts of the spectrum as well. So with that, we'll kick it off. John will lead off with the first topic or question for the panel.
Okay, thanks, Julie. And just to get everyone involved, I think we're going to start with a question to the whole panel, and maybe we'll start with Paige on my left and then just go down the table. But we're here at the FCC today, so we've been a bit FCC focused, and millimeter wave is exciting, but the FCC's role in millimeter wave is just one part of a much bigger federal government spectrum agenda. So I thought we would just start and ask everyone to go down the table and just talk a bit more broadly around in their roles, their agencies, what that bigger spectrum agenda looks like.
Okay, thank you, John, and thank you for inviting me to be here. One of NTIA's top priorities, I think most of you are familiar with, it's 500 megahertz and beyond. And that's really to ensure that we have a very robust process in place to not only meet the President's 500 megahertz goal, but also to ensure that we're continually looking beyond that initial goal. And we've been very successful. We have very strong processes in place. In particular, our success is based on the strong interagency processes that we have in collaboration and increasing collaboration with industry. And another key component that's more recent is the Spectrum Pipeline Act that allows us to more flexibly apply the spectrum relocation funds for advanced spectrum planning and research and development to support making additional spectrum available for commercial use. And that's a key component to helping us create a sustainable pipeline. It also allows us to make sure we're maintaining and enhancing critical federal capabilities. So we will leverage these foundational elements as we extend our focus into millimeter wave, specifically 5G, more generally speaking. And as we've talked about today, 5G is not one thing. It's a breadth of technologies and an ecosystem of capabilities to satisfy a diverse set of requirements, requiring a diverse set of technical characteristics. And again, that requires low, mid, high band spectrum, but what we've heard clearly from industry, particularly over the last few months, has been a key gap is on those higher frequency bands. So we're very excited at NTIA with Spectrum Frontiers and the opportunity it provides us not only to respond to those gaps that industry has identified, but also to look at new opportunities for unlicensed, licensed use, as well as additional sharing opportunities between federal and non-federal users, as well as something that we haven't discussed too much has been dual-use technologies to better satisfy both private and public sector interests. And we talked a lot about sharing, so I won't spend too much time, but like the lower bands, the higher bands have characteristics that are particularly good for 5G. They're particularly good for some government applications as well. And we do believe that it provides a new level of sharing approaches that we can leverage to enhance sharing between the two. And as we address these new sharing approaches, one thing we haven't really discussed today that I wanted to mention is that we have to more effectively integrate enforcement capabilities in terms of our technologies, our architectures, our policies and processes. And if you recall the discussion earlier today in terms of security, we have a huge opportunity here that we can do it right from the beginning. And we have to take advantage of that opportunity. So I'll wrap up with this first question, that key to our success is collaboration. And it's not just between government and industry operators, but it's also across research, development, testing, and evaluation. And collaboration and trust really will be the key to us being able to fully exploit these opportunities ahead of us. Thank you.
Hello, thank you for having me. So from a spectrum policy, the question was asked, what is NIST is doing with respect to spectrum policy? As you all know, NIST does not work on spectrum policy. However, a lot of what we do directly supports the spectrum policy, work with our sister agency, NTIA and FCC, to help develop sound policy. So from the NIST Communications Technology Laboratory, we're focused on advancing measurement science and measurement science infrastructure in support of next generation wireless R&D. And how we're doing this, when we look at millimeter wave, for example, last summer we launched the so-called 5G millimeter wave channel model alliance, and that's an open consortium that anybody can join that is looking at a shared knowledge of millimeter wave propagation, looking at models, measurements, data repository that people can have access to. And to date, we have over 90 participants representing 45 organizations worldwide. Taking a step back a little bit, looking at spectrum sharing, as we believe this is a big pillar of the future, and 5G. NIST has been involved and had an active program in spectrum sharing. It encompasses us working with SDOs to accelerate the development of spectrum coordination technologies. Forums like the WIN Forum, for example, looking at 3.5 gigahertz spectrum access systems. Also looking at advancing the state-of-the-art in research in spectrum sensing and monitoring. So last but not least is we're also looking at setting up a test facility in Boulder, Colorado, looking at validation and developing test methods for interference and analysis and coexistence.
You're next. You're going to call my name. I can school. So thank you, FCC, for the opportunity, as usual, and thanks everybody for coming out today on this beautiful, beautiful day. I'd rather be outside in that 80-degree weather, sitting back smoking a cigar and sipping on some scotch or something. But honestly, I'm excited about the opportunities that are before us today. For a couple of reasons. For one reason, I'm happy we're talking about some of these higher bands that are on the table versus just the sweet spectrum below 3 gigahertz, which is crowded as well, as everybody knows. But in a perfect world, we wouldn't be here, right? From a DoD perspective, and we would also like to have exclusive spectrum to be able to do our missions and be able to do the things that we want to do. Clear out everybody, maybe just share with some of the other federal agencies, as I've heard some of the earlier speakers talk about. And trust me, my leadership would like that as well, because it's easy to do. But the reality of the matter is things have changed, not only for the department, but for everybody. And I'll just speak from a department standpoint of things that have changed, just kind of going down the list. Our RF requirements and spectrum requirements continue to increase. Our global operations are becoming more and more complex. Our enemies are evolving their threats against us, so we have to be able to do the things we do to be able to be flexible and adaptable, to be able to move around in the spectrum, to be able to do our missions no matter where we're at. Industry's requirements are going up as well. Global requirements are going up. It's getting more and more complex. So no matter what I want to do in a perfect world, no matter what my bosses want to do in a perfect world, the reality of the matter is we have to have more spectrum sharing as the new normal. There's just no other way around it. I wish I had an easier answer. You know, I don't want to go off and spend and expend more DoD resources to try to come up with more innovative technologies to try to figure out how to share. But that's the reality of the situation. We're being also asked to share with partners that we've not been asked to share before that are aggregated everywhere. So all of that stuff combined has caused the department to say, you know what, we got to do things differently. We can't continue to do business as normal. So what do you do? You know, how do you do? What do you do? How do you facilitate all of that stuff, right? So I can get up here and say all of these things, but as we go through the panel here today, I want to talk about some of the foundational things that the department has put in place, not to just come up here and talk about more spectrum sharing and just walk away and let you go figure it out. Some of the foundational things that we've put in place to facilitate that spectrum sharing, you know, from a policy perspective, from a strategy perspective, from a technology perspective, from a partnership and collaboration perspective, from a testing perspective. So I'm not saying let's go do all of this innovative spectrum technology stuff, and trust me, we put in place the NASDAQ and the CAC to verify, trust but verify, that the technology does what it's supposed to do. For the first time, at least that I can remember, as we develop these technologies, we have federal regulators working with us on these technologies and working with us as we move this ball forward. So as we develop these technologies, we can develop the regulatory and policy aspects to support the technology for the first time that I can remember on a holistic scale. So I look at this as a great opportunity, not just for the department and the federal government, but for the United States, as we try to figure out how we balance the economic needs of the country as well as the national security and federal needs of the country. So I would urge you. It's an easy way to just clear, but you clear me, where do you move me? When my boss asked me, tell me where to go. I don't know where to go, boss. So we got to come up with better, more innovative ways to do this, and we've worked together with NTI and FCC to put in place the foundational things that would help support spectrum sharing now and in the future. Thank you.
Thanks, Fred. Renee?
Thanks, Julie. And first, I just want to thank the FCC for putting on a really terrific workshop. I've thoroughly enjoyed the panels and the demos, so kudos to all of you. I know how much work it takes to put one of these days together. And thank all of you for showing up. The fact that there are still people in the room at 3:30 on a beautiful day means that there is an awful lot of interest in the topic that we're talking about today. In terms of OSTP, Office of Science and Technology Policy, we think a lot about the intersection of technology and policy. Isn't that crazy? And wireless broadband and broadband generally is a big priority for the administration, a big priority for OSTP. OSTP is actually the home of PCAST, that had the 2012 report on sharing and pushing the envelope in new technology and policy ways that the FCC recently implemented and is going to continue to implement, I'm sure. And it is all about sharing. It's about, to borrow a phrase from PCAST, going from a culture of scarcity to a culture of abundance. But that is hard. And part of what we're doing at OSTP is focusing on advancing and pushing the envelope on both technology and policy, frankly, in ways that makes everyone uncomfortable. If everyone were comfortable, we probably wouldn't be pushing far enough. And as we sit here today and we're talking about millimeter wave, of course there's a lot more going on in spectrum. But if you do think back even to the beginning of this administration, no one was talking about millimeter wave. It really was the next frontier. It was not spectrum that was considered particularly useful. No one could have predicted that there was going to be so much interest as we all sit in this room. So I would encourage everyone to continue to think big thoughts, continue to think about sharing, continue to try not to just double down on the way we've always done things, because as Fred said, that's just not going to happen anymore given the vast demand by everyone for more spectrum resources. And I'll close just by saying that one of the things that we're able to do at OSTP is try to bring people together And as Julie mentioned, my colleagues on the panel, we talk to each other all the time, not just at workshops, and try also to talk to all of you, from people who have been established in the wireless business for decades to new startups who are really pushing incumbents and other new entrants to think of new creative solutions that are going to, at the end of the day, bring results to our economy and to our citizens.
So, often folks will say, well, there's not enough R&D going on. When in fact, I think you heard earlier today that there's really an enormous amount of R&D going on at universities, in the private sector, and across government. So when I think about R&D, there's a couple of ways you might consider it here. One is, things where the government has traditionally invested in helping to develop technologies in spots where there might be a gap. And then there's also research that's been going on relative to advancing sharing to get more use out of the spectrum. So on the research front, anything you might comment on that you see where more research needs to be done relative to millimeter wave, or work that's going on now? I know in Aston we just mentioned a couple things, and the consortium and so forth, to pave the way for these technologies to be rolled out. Anybody?
I'll kick off. Just to mention, for those who may not be familiar, NTIA has the Institute for Telecommunications Sciences out in Boulder. That is our research arm and works very closely with NIST, and in fact is partnered with NIST for the Center for Advanced Communications and the National Advanced Spectrum and Communications Test Network, CAC and NASTN, that we mentioned earlier. And CAC and ITS's focus really is all about spectrum sharing, but they also have fundamental areas such as propagation. Many of you have worked with ITS on propagation, and some of those fundamental areas are less mature, when we look at millimeter wave. So I think part of what we need to do and are doing is to understand where those gaps are, even in the fundamental areas of research that we've done for a long time, and ensure that we're addressing those gaps, and that's part of the process that we're working through internally.
Propagation, I think modeling is key, and that's one area that we understood that needed additional research. We do believe and support in the pioneering work that Professor Rappaport has done, and we work with him on additional measurements and models, and with the entire community. We believe that areas like this require more than just one organization working on it, and that's why we want to pull our heads together in order to really bring accurate characterizations and models. There are other areas, for example, for spectrum sharing and coordination. Technologies out there, we believe there's additional work that could be done in terms of metrics, measurements. How do we assess interference? How do we assess, is a device working properly? How do we assess these behavioral metrics that are not just number of dBs, but we know exactly how to assess. So things are a little bit more difficult in that area. It requires probably more attention.
So we've worked with industry to establish the National Spectrum Consortium. So this is our partnership with industry, academia, the federal agencies, to work on spectrum sharing technology solutions. One of the basic foundations for this group, and I think this is important as we start talking about spectrum sharing going forward, was to establish a vector that the entire membership would be pointing in the same direction. And the basic premise for their consortium is spectrum sharing. Right. So within that forum, it's not the spectrum guys. It's our big government system manufacturers. It's you guys on the industry side. It's academia. It's some of the non-traditional companies out there. So we're looking to bring together the best and brightest across the country on the industry side to help us solve some of these spectrum sharing technology solutions. The intent there is not for us to come in here and tell you what to do, but to put our our problems in your hands and have you come back to us and tell us what the best options are and the best opportunities and technologies are out there for us. This isn't one of the your typical new technology kind of things. This is looking at, as a first step, some of the more mature technologies, because we're paying attention to try to get things out there as fast as possible, because we understand the need for speed and the need to get stuff out there as fast as possible. That's the first thing. The second part, we put in place a $1.25 billion contract. I'm not going to talk about an other transaction agreement and what that is, but it basically gets us around a lot of the red tape within DOD and some of the typical long acquisition cycles that it takes us to get through in the building. This allows us to get things to the field and get them in your hands faster. One of the other aspects of the consortium that's important is the technologies that will be developed within the consortium. And we're looking at things like further maturing MIMO and spectrum aggregation technology kind of things, dynamic spectrum access for radios and other things, is to develop the technologies in a manner that not just DOD and the federal agencies can use them, but they are available to industry as well. So we're trying to solve the problem not just for the department and the federal government, but for the country and for everybody, because the more that everybody's using similar kind of products and technologies, the sooner we can start developing and working in an environment that's dynamic and cognitive and adaptive. Because ultimately, if we're talking about spectrum sharing and more spectrum sharing, you got to be able to have systems that are kind of, have that kind of capability in the future. So that's our contribution to spectrum sharing from a technology perspective. So as I said earlier, we're not just doing a technology thing and we're saying trust us. Well, we put in place the National Advanced Spectrum Communication Test Network, which is where we would go and test those capabilities. So it's not just trust me, but trust and verify that the technology does what it's supposed to do in partnership with you. So you'll be part of the NASTN construct when we bring these technologies there. So you can walk this along with us. So at the end of the day, when it comes off of NASTN from a testing perspective, the technology does what it's supposed to do, and then we can all together come back to the FCC and NTIA and say, we agree this is a good thing. Thank you.
Do you want to chime in, Renee? I don't know about you. Last time I had a fireside chat with my friends, we didn't have a set order of speaking every time. So
this is the FCC.
it's the government. Did you want to say anything, Renee, on that last question?
Sure, I'll just make a couple of points. It is great that there's so much good work going on across the government in individual agencies, but also literally across the government with things like the CAC and the NASTN, ITS doing things in support of other agencies. But at the end of the day, it really is about all of you all, you in this room and your companies who are pouring in R&D. Chairman Wheeler mentioned this morning that the U.S. doesn't engage in industrial policy or government standard setting, and that's really one of our strengths. That's part of the reason why we were leaders in 4G. It's part of the reason why we will be the leaders again in 5G. And so we certainly want to work with you all, but our efforts can only support the much bigger, broader efforts that you all are doing.
So I'm going to mix it up a little bit. I'm going to throw a question back to you, Fred. Paige mentioned dual use, and Fred, most of your first comments were all about sort of the new approach to thinking about sharing and having to be more creative going forward. One of the themes from a lot of the morning discussion was, we're early enough in 5G that the technologies are still being shaped, and we talked about it in the security context on one of the panels. I guess from the DoD perspective, this idea of, are there going to be some commercial technologies DoD also could take advantage of? How does DoD really think about those opportunities to have maybe expanded access to new bands? But what does that really look like, maybe a level more deep in terms of going forward for DoD?
Yes, so I can attack that from two different perspectives. I think as we evolve 5G and IoT and everything else coming off of the industry side and ultimately defining what that is, I think the department will be one of your customers. As long as you can employ the right encryption and all the other protections and cyber things that we need to incorporate to make it safe from a military TAC training and operational perspective. But on the other side, we got to figure out how to help facilitate that from a sharing perspective. And one of the things that I've seen over the last few years in this job from two different perspectives. One is industry a lot of times has no idea of the environment that they're getting ready to have to engage in from a federal government perspective. What kind of operations are actually going on in these frequency bands? We can do a service to industry by being a participant in their standards bodies and some of their regulatory forums to help them better understand what kind of environment they're going to be operating in, to try to help shape their technology solutions going forward. I would use 3.5 gigahertz as an example. It's hard, and this is going to be hard as well. But I think one of the most important things, and I hate to do it, but I'm going to do it, and Chairman Wheeler said it the other day at the Satellite Industry Association dinner, and I agree with him. You got to have folks sitting down talking to one another. That's the only way to do it. And the only way we're able to come up with the AWS-3 agreement was to sit down with industry and forge a way forward on that. 3.5 gigahertz is another one. We have to sit across the table from one another and figure out together what's the best solution for these particular bands. We got some smart guys on our side, and you do too. And it's not just the spectrum guys, but it's the technology guys sitting around the table with the understanding and the goal being the same, that we're here to try to solve a problem, which is spectrum sharing going forward. So that's my perspective.
So for the president's goal of 500 megahertz, and in most of the day we've talked about the millimeter wave bands and 28, 37, 39, and 70. Sounds like a play in football. But maybe if folks could say a little bit more about where we are on the 500 megahertz and the things that we're working on, and in part just playing off of Renee's point, because we haven't been approaching this as the 5G bands. From our point of view, we provide flexibility in all of the spectrum that we make available, and then leave it to industry to decide how to use the bands for whatever we end up calling 5G. So maybe a little bit about what we're doing on the 500?
I'll take that. To kick it off at least. So we know we're about halfway there. We have 245 megahertz that has been made available, and we've got approximately 4 years to go. The 500 we need to make available by the end of year 2020, and I'm very confident that we will get there. I think that we have some continued improvements and some challenges that we need to address, but again, I'm very confident that we will reach that goal by the end of 2020. I would say, I'll give you a couple of examples. A couple of the improvement areas is to continue to improve our analysis, modeling, simulation, continuing to do a lot of that in collaboration with industry. Not only the regulators, but also in collaboration among the agencies and industry stakeholders, and that's very important. I would say that one of our most challenging areas is ensuring that we are able to get commercial prototypes when needed to do testing and validation of the analysis and modeling that takes place. 5 gigahertz is a good example. That's an area that we're looking to get some prototypes, and this is both in the 5350 to 5470 megahertz band, as well as the 5850 and 50 to 5925 megahertz as these bands move forward. So I encourage everyone in the room that would participate in that to understand that that's an important component as we move forward.
No more than 500?
I defer to
NTIA. Like your 600?
Yeah, Renee, let me throw one down to you. So, you touched on it, and absolutely right that the leadership OSTP has shown, and really how far the debate on these topics have come in the last couple of years. So here's, of course, the million-dollar question. We're here in the last year of the administration. You're down to 10 months or so. What are the big final things you're trying to get going? How can people in this room help you do more? Because I think that the focus has been incredibly valuable, and time for this administration is running out. So what are the big priorities here at the end?
Certainly doing everything we can to advance the 500 megahertz goal in partnership with everyone at this table. We're halfway there, but that means we have half to go, and it is a combination of both licensed and unlicensed spectrum. We look at the 5 gigahertz bands that Paige mentioned. That's an awful lot of spectrum there, and there are very hard technical and policy challenges in both of those bands. But like Paige, I have high hopes for those bands as well as other bands that could count towards that 500. This year, we'll also be working on advancing the President's second spectrum memo that talks generally about accelerating sharing, and that really is the theme for today, is sharing, and something that we keep in mind over at OSTP. We'll be watching closely some of the bands that have already been made available, specifically AWS-3 and 3.5, both of which were the result of some big leaps forward, both in technology and policy. And we'll be watching very closely the incentive auction, looking over to my right. Again, talk about a tremendous advance, certainly in spectrum policy, and watching those bands for progress, but also lessons learned as we move into the future. And while it may be coming towards the end of this administration, there's a lot that we can do to set up for future success in future administrations that come next. Certainly looking at traditional pipeline, low, middle, and high band spectrum, we have to keep looking out that 5, 10, 15, 20-year window because the demand is only going up, and technology will permit more efficient use, but the demand is going to also continue to go up. And of course, a priority is millimeter wave and watching what the Commission does here, and hopefully seeing more sandboxes in policy and technology. I sound like a broken record here, but it really is true. The Commission, in terms of licensing, we heard in the lively discussion at the previous panel, has suggested a number of different models, a quasi-traditional licensed model, quasi-traditional unlicensed model, and then a third hybrid model that makes a lot of people uncomfortable. Maybe that's not such a bad thing. And I'm hopeful that as we all continue to think about these particular bands, that we do step out of our comfort zones collectively and think about whether it's the FCC's hybrid approach or something else. Maybe that could be a good technology sandbox for the next innovators that we haven't even thought of. And I'm also hopeful that there will be some non-traditional voices in the room. We've heard today about some industries like agriculture, manufacturing, sports arenas, healthcare, automotives. And these are not traditionally people that we see around here in the halls of the FCC or at NTIA, but I hope that those folks will become more engaged as well. And generally, just pushing the ball forward as far as we can. There will be many people who come after me, but I want to set that up for success.
So this is the sort of question that'll come from your spouse or your parents or your kids. So we sit and talk about all the wonky stuff about spectrum sharing and megabits per second and latency, but what does it mean to consumers? So you're asked by your son or daughter or your wife, what is it you do and what does it mean to me? Thoughts on that? We don't know.
I'll start off. No first step.
Yeah.
Oh, I think there are two parts to this. Everyone has grown to depend on wireless everything, and people can understand that it would be great to have better, faster, cheaper, more competitive options for things like wireless broadband, your smartphones, your tablets, your laptops at home, whether it's licensed and looking to a post-4G world on licensed spectrum, or whether it's the next generation of Wi-Fi, whether that's Wi-Fi or something else. But it's also about enabling the next technology that you can't live without. And we don't know what that is. And there's been a lot of talk about unknowns today, and that's part of what's so exciting and part of why I believe we should all take a flexible, open view. And I can't tell my parents necessarily at home about what exactly it will be, but hopefully it's something that in 15 years we'll look back and think, how did I ever live without that?
going to take it a slightly different approach. So consumers are also citizens. And it's them understanding that they're not only receiving the consumer benefit, whether that be through entertainment, better health care, other activities, but also so we can look them in the eye and say, when you get on a plane tomorrow, you'll be able to get to your destination safely. It's about telling a mother or father that when a hurricane is approaching their city, they'll be warned in enough time to protect their family. It's about understanding the phenomenal research that's done, for instance, in the space sciences or research on the International Space Station that creates breakthroughs in multiple areas to include medicine that affect us now and into the future. So it's about them understanding not only the consumer benefit, but the citizen benefit as we make these spectrum policy decisions.
Why don't we wrap? I mean, I guess
I want to keep going.
I mean, can we ask that last question? So our last question is sort of builds on the last one. Be ready though. So we're gonna ask our panelists just as individual consumers yourselves of all the things you've heard about today or in all of your work on this topic. So what's the thing about the future 5G world that you're most looking forward to, most excited about? Is it getting that 4K video to your smartphone, or what is it? Anybody?
We heard earlier today, keep track of the beers in the fridge.
So I'll talk about 5G real quick. So I think one of the things that excites me is just being able to as a consumer, being able to access, everything from a mobile perspective, no matter where I'm at, whether I'm in my car, whether it's my refrigerator, whether it's whatever, just the opportunity there that 5G or IoT and all of this stuff affords us. I think it excites me, not only from a consumer perspective, but from a DoD perspective. But I think one of the things that I think that I'm looking past 5G is how do we evolve to the next step? We get to a point where you got machine-to-machine kind of communications, and the radios and the RF is doing its own thing, and systems are talking to each other, and you get all of these people out of the loop. And let the systems and the capabilities determine what kind of frequencies they need and what's out there and what's accessible and how do they communicate to make that all happen. So, that's what excites me. I'll be gone, retired, maybe sitting somewhere in a rocking chair, but just thinking about the evolution of how do we get to that point, where radios and comms are all talking to each other, and we no longer need humans in the loop anymore.
Engineering and perhaps a technology point of view, I'm very excited about the seamlessness, the adaptiveness, the agility. Earlier today, we heard about throwing the kitchen sink, and we can make 4G work for us and do pretty much what we want to do. But looking to the future, we're looking at something more elegant, lighter, simpler, so that we don't have to carry 60% traffic in signaling, and we can do a lot more with data. So a solution that is more coherent, fits together, and it's not just Band-Aids.
And I'm just interested in seeing what it really is.
So we have 7 minutes left, and so I was tapped to do closing remarks, and I'll just do them from here. I think that's the easiest thing. So, folks have talked about 5G often in the context of, that's in 2020. It's real, and it's here. I mean, it's here in this building. So, yes, there's a lot more development that needs to go on and so forth, and that will, miniaturization and so forth. But we know that technology works. And so that's really important. The old concepts, and there's a habit of doing this, are falling away. And I've been at this long enough, and I've said this in other statements before. Early in my career, mobile has to be below 1 gigahertz. Has to be below 3 gigahertz. Beachfront property is 3 gigahertz. And so here we are talking about things up at 70 and 80 gigahertz and all. So I will commit to never again say what the upper limit is of mobile. Some of the other concepts, of ubiquitous coverage, because I think in all the prior generations we always thought about it in terms of almost isolation, that that system was going to cover everything. What you heard today, I think, was a lot of talk about heterogeneous networks, and that you won't have the networks that are solely millimeter wave, but they'll be used in combination with other bands. So when we talk about the need for spectrum at low, medium, and high bands, it's really all about being able to use the different parts of the spectrum in the best ways to combine to get coverage in the capacity where you need it. And they have to work together seamlessly. I think we heard that also today. The applications. We've heard about so many different promising advances, some of which are already being deployed under the existing technologies, but will only get better and have more capabilities as we go forward. We know enough that this is exciting. We know that there are applications for transportation, for healthcare, for education, even potentially for getting better service out to rural areas. So there's plenty to be excited about, and at the same time, there's no way we're going to be able to sit here today and figure out everything that somebody will innovate. Years ago, when we were talking about 3G or 4G, nobody was imagining things, at least publicly, about the apps economy and what smartphones and tablets would all become. And that's terrific, because what we want to do is create a framework that's flexible enough to allow people to innovate and do the things that we're contemplating and the things we haven't thought of. So flexibility is key to that. I was encouraged by some of the discussions today about sharing and people working together to solve some of the problems and gain access to spectrum. All of the tools seem to be there. What we need to do is make sure that folks are talking to each other to try to develop stakeholder solutions that are going to work best for everybody. So the constant theme I think I heard today to the FCC was move and move quickly. There was nobody that I heard from among the speakers or the questions that said, we really don't know what this is, so you ought to wait a year or two. The constant theme was keep it moving, people create a framework where people can innovate, and that's what we aim to do. The demos I thought were terrific, and I hope you all, if you didn't have a chance to get over there, there's still time. They'll be up till 5 o'clock, I believe. So by all means, get to get a little bit of an appetizer for 5G. For the thank yous, I wanted to thank Chairman Wheeler and Commissioner O'Reilly for getting us off to a terrific start this morning. To all of our speakers here today, many of which came from different parts of the country, we really appreciate it. I think we had a terrific lineup of speakers. I know I learned a lot, and I hope you did too. And I'd also like to thank the Commission staff who put this together. And I'm going to rattle off some names here for you. I thought that I'd have them stand up, but they look so comfortable where they are. So Brian Reagan, Michael Ha, Cecilia Solhoff, John Schaubel, Bob Nelson, Stephen Buenzo, Sari Tai, Jeff Goldthorpe. In the print shop, Janet and Aaron, who I understand were here till about 9 o'clock last night. And the AV staff, Jeff, Steve, and Richard. So I thank all of you for coming and for helping us get done on time. Have a great evening.